work in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Our customers have been trusting us for over 150 years now. Our apps rank amongst the best banking apps, and more than 1.9 million customers are already using our apps on a daily basis. We have big plans and want to extend our feature stack. What can you expect if you join our digital banking solutions team? A highly motivated agile team setup, a balanced mixture of talents and professionals, a collaborative environment with colleagues of 40 different nationalities in 4 locations, a scalable and modern technology stack with Microsoft Azure and Google Cloud Services, a flexible API-based ecosystem, CI/CD with up to 30 releases per year. We want to grow together with you. Check out our latest job postings.
Azure Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Our customers have been trusting us for over 150 years now. Our apps rank amongst the best banking apps, and more than 1.9 million customers are already using our apps on a daily basis. We have big plans and want to extend our feature stack. What can you expect if you join our digital banking solutions team? A highly motivated, agile team setup, a balanced mixture of talents and professionals, a collaborative environment with colleagues of 40 different nationalities in 4 locations. A scalable and modern technology stack with Microsoft Azure and Google Cloud Services. A flexible API-based ecosystem. CI/CD with up to 30 releases per year. We want to grow together with you. Check out our latest job postings.
Azure Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. The ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Our customers have been trusting us for over 150 years now. Our apps rank amongst the best banking apps, and more than 1.9 million customers are already using our apps on a daily basis. We have big plans and want to extend our feature stack. What can you expect if you join our digital banking solutions team? A highly motivated agile team setup, a balanced mixture of talents and professionals, a collaborative environment with colleagues of 40 different nationalities in 4 locations, a scalable and modern technology stack with Microsoft Azure and Google Cloud Services, a flexible API-based ecosystem, CI/CD with up to 30 releases per year. We want to grow together with you. Check out our latest job postings.
Cold place. Be cool. I know, my idea was to start the quad. Not sure it's a good one. This means 15 minutes late.
I think it's starting.
Yeah, that's quarter past the hour, 15, 11 and 15. And the next presenter will have a huge problem because he will have practically no break, but I can get my stuff.
It could be worse. It could be Andrea Mancia instead of you.
Yeah, but he's on the airport, eating yet again. Uh, I really do not miss doing trainings that much, especially in Holland and some other strange places.
My next one is Tuesday.
Training?
Yeah.
Yeah, which one?
The part of the marathon. I will take the first topic.
Hmm. But I still need to, because I want to remain a certified trainer, so I need to do at least one. But let's start slowly. So, what we're here. The wife did not send us to buy vegetables and end up here at Global Bootcamp Azure. So let's first thank our sponsors. Really, they are doing a great job. And okay, let's start with this. We're going to talk today about Azure Percent. This is an offering from Microsoft of running models, artificial intelligence models on the edge. It's a combination between hardware and software. Okay, but this is not how you do it. At first, you need to, let's say who you are, establish your credentials. So I'm coming to Bulgaria for the last, I believe, decade. I'm hoping that each time I have a different presentation and let's say a different one from the one before. What it is, I'm now working at the EPAM System and Solution Architect, you know EPAM. And what are my other credentials? I'm Microsoft awarded me from the year 2011, each year the type of most valuable professional. And I'm in two categories, Microsoft, Azure, and Windows development. This cross-section says IoT. And I'm also Intel Software Innovator. What other tricks I have on my bag? I have here is the timesheet of this presentation. And I'm, let's see, I'm still on track. And I will read one slide. Also, we do not have a lot of slides. Let's start first. Has any presentations? You know what's it missing? So let's. I'm looking at you, and I believe that. Somebody tell us something about domains. Let's say hardworking, beautiful. What you can say when you're talking about Romanians? Lazy. So okay, lazy. I will let you do the presentation. 2 questions, and I have a lot of chocolates that I want to get rid of. Anyhow, there are people even though they have the Santa Claus on it. So, okay. The next slide. What would be? Okay. First, let's try to get to the story. Let's see what we have to speak about. Why now in my computer vision? Anyhow, we do not see it that much, but because of Microsoft and because other companies, artificial intelligence has become a whole, let's say, low-hanging fruit. You can easily do something. I'll tell us our story. It was, let's say, before EPAM. We are working at an IT company, and again, we're talking about domains. They need to put on something a number of screws. And they discover 2 things, that they know how to count, and the second, they are much more powerful than they are looking. So actually, they put the wrong screws and the wrong number. So what was the approach to this? Usually, you are using a weight counter. This is okay. The weight counter is using an analog digital converter, which refined the number reading at each cycle of the process. So it's not a fast process. Even on computer time stuff. Also, there are screws that are looking the same, and they have almost they are different, but they have almost the same weight. So our solution was on the very small budget. Let's try to use a camera. So let's take a picture of the screws and let's see what's happening. So we try this, and I'm going to show you again some of our journey. We see what we have around on the same budget. So the budget was the same. Let's take a peek picture and let's run a model on top of it. Okay, let's try to get, you know what, it's this. Okay, run it around and back. As a question, any idea where it is the build? Even pass it around. Where, in which town? I'm from Timișoara. In which town was this developed? Even though it says in Delft. On which town? Timișoara. Yeah, you get a job. So this is okay. What's the story of all this? Okay, to understand how the artificial intelligence and computer vision, on which I'm gonna talk more around it, it works. You have a bunch of pictures. You're running someplace on or servers, usually in the cloud. And each picture has a, let's say, classification of something. We said that this is a screw of the right kind. And you run, and you create a model. And then you are getting this model, you're running this model against a new feature. And you get a result. Okay. The results are, let's try to, something that you remember, the results are yes, no, or a percentage. Yes, a percentage, sorry. Percentage. Okay, what's the problem with this? If you're reading on software, PC or something, they are not that, let's say, performant. So it comes in processors. For example, if you want to have a stupid Raspberry Pi, you want on this model, it will somehow run, but it will be very bad. So it comes class of processor. This is a special processor just learns. The process of running another picture on top of the model is called inference. So this is the first one from Intel. Movidius is the company that was bought was from Timișoara, and there is also NVIDIA. So these are specialized for computer vision. You stick it in almost anything and everything, and you will get a much better performance than before for this inference. This I'm going to show you a bit later. First, I'm going to talk about Intel's vision in this, because it's an interesting story. Okay, Intel is a company at some crossroads. You have ARM, you have AMD. They need to see same like Intel, same like IBM. IBM who did not get it around. Nokia who again did no way. Microsoft who did found the way. They need to know what to do in the future. So they are somehow betting on this computer vision and this kind of chips. What they seen as a problem, and I can show you this slide. They don't have that much. They seen that out there are 1,000 types of models. You have TensorFlow, you have Coffee, you have a lot of models that are out there, and usually very few will see in this demo today. We'll see two computer vision models that we did not train. We're taking them from out there someplace, and I'll run it on hardware. But they understand hardware, so I said, okay, you're running these, but they are not optimized. So let's try to. So what is their idea? So we take some models. They have also something called Model Zoo, on which you have pre-trained models, and you run it through Model Optimizer. Model Optimizer first look at general stuff, like look, you have too many layers, and to solve this. And second, tries to look where you are trying to target, and the models look like graphs. You have numbers, and you have nodes, and each node has a weight, and the weights can be represented as integers or as a double. It depends on the platform you have the performance. So they save it intermediate model, which is an absolute general model that all Intel hardware knows to interpret. User application and inference engine. What what's the advantage of all this? You get model, and you write one code for any model from Google. Write my code, and also it's not optimized. Okay, this stuff. Open line. It says wonderful. It should work. What is the fly in the ointment? Their code is highly complex. You need to spend 1 month from their examples to get a production code ready. When it works, it works. But that's the problem with their approach. And this is a slide from Intel. So run from the code, anything. I just take a sample from Intel and let's run it. So I'll put the stick. There's sample. Let me. First, something. These are the pictures that are gonna. There is the problem with the. Okay, open one in this time. There I have some strange motion. There is now very late in the year 2022. It's strange versioning, and also breaks the CMake. You need to set up. Anyhow, if you are knowing a bit of programming, you get around. It's open here. So, what we're going to have the same code on CPU, GPU, programmable gates array, open file. And let's see it at work. Let's run will be the and now we'll work with Myriad. Myriad is the name of the processor inside of okay, enter inside this. I cannot show you Intel neural stick. So what it's now doing, it's getting the model that will do for the H picture, pushing the model to the neural stick. This is something that won't happen in the real world. You push it once and you just run new pictures. What we're going to see, what we recognize will take a bit. And now it's still getting from the zoo, the model. Also, it's creating some software. Again, a bit boring, we'll do it later. And also, we're having a lot of chocolates. Features that do not recognize. Let's try to get from you what's happening. And I'm hoping the internet it's there. If not, we can still move on. Oh, it's moving. Okay, question up to now. Asking yourself, what's the connection with the person? Patience.
With what the connection?
With percept. No, the teddy bear is not called percept. But still, get the chocolate for. Again, it's working still to 2019. Again, it's slow like, and I'm not sure why. Now, again, this is not inference, now it's creating the solution. It's getting the model, it's creating an executable, and then after all this is finished, we'll push it on the stick or on whatever it is, and run this model. How to say, Intel, it's not alone on this front. We'll get back. We'll see that also NVIDIA has the offerings. And I'll say
This is with Intel's chip?
yeah, with Myriad.
With the ones you showed?
Yeah, on that stick will be run the model. Now we're just preparing the model and it's good one.
How long the thing?
This depends. This will be something like 3 minutes. On this, because also this is the same chip. inside below this, it's a bit faster. We also see it. I think the internet's not playing. So, and now it's loading the model. You see it on the Myriad plugin. So this means that it's sending over to the stick all the stuff. And also send the picture. He said, I will take the first picture and I'm loading the model on top of it. So you see, it recognizes a car and the license plate. So let's pause it and move to the rest. You see the performance up there. It's 2.5 frames per second. So I do not know why this is that slow. But now let him, let's say, a couple of pictures. The screen sharing. That's the flying on the ointment. I'm not sure. We'll see later on what if will affect also the percept. And in fact, I know that we're gonna drop on the screen sharing. You see here, recognize the car as a truck and no license plate. So the idea was to close it. Okay, this will take forever and one day. So let's try to get to the conclusion I want to. So I took the time, sometimes before, to run the same sample with the same pictures 3 times. Once using the CPU and once using the Myriad. You see bigger frame per second are better. So this stick, it's consistently better than the Intel 5 CPU. And this stick you can add for Raspberry Pi and you get this performance. So there is something to having a hardware inference. Let's try to look at the next picture, because if you remember, any idea what's the problem with the number plates? Why it does not see them? And here it's any idea for a chocolate.
Another number at the back.
I said, yeah, okay, but not quite. Again, to learn a new term, to understand it's doing what it's doing, still, it's called observability. Here the problem is in the color of the number plates. It's different shape. So the rule of the thumb, if you have problem, also that we have with our screws, if you remember the stories, our screws sometimes are blue. The model was, okay, the solution is to use a black and white filter. And where are the number plates blue? In China. And the problem is with the shade of blue. Moving forward, this will have a couple of pictures. We'll get back to it. Okay.
So there will be a similar issue here with the pneumatic cars that have red numbers.
Yeah, but if you are using a black and white filter, it will be no issue. That was my point. If you're having a problem with the model in computer vision, apply a filter. A filter to put away the problem with the color.
In your case, why was the issue with the specific shade of blue?
Because this is
It
how the
was
model.
too light.
No, the model was trained on colored pictures. You need to train it on black and white, control black and white. And also, the camera does not need to be that smart. The stupidest camera is better because there are not that many pixels for millimeter. So you are working better with the stupidest camera. Okay, on this field, Microsoft saw the interest, and they created something like Azure Bulgaria. This is the main theme of this. And this is a hardware and software offering, of course, working with Azure. This is the version 1. You find a lot of information up there on the internet. I do not know if you can get the hardware in Bulgaria. What's that? It's a central unit that runs a Linux Mariner. This is a distribution of Microsoft Linux. We have a camera. This is the vision. Here you have the Myriad chip also. This supports 2 cameras. Here it's only 1 installed. And this is for sound. We have 4 microphones and all this. This is doubled by an Azure offering. We'll go up to all of this, up and around. Now let's talk about the Microsoft vision of the edge. Anybody has an idea what Microsoft thinks that you should run on the edge? How they think to do it? Okay. Yeah. Say again.
Mostly cache.
Okay. So Microsoft is a software company. So I said, okay, we have some offering in the cloud. This is IoT Hub. This is IoT Hub, which is running almost anything. So if you want to move to the edge, let's move everything like containers. So you're moving a container with IoT Hub on the edge. You're moving your payload, which it should be, and also a container to communicate between them. So on this Linux, you're running Linux container with all the. Let's run a bit through the setup. That will be, and anyhow, I'm hoping that at the end we'll have more time to for demos. So first, to do a setup, I need to take it out of the power and let it a bit. You ask yourself, why in the earth I'm showing you this is development either created by Asus. You can still use it in our commercial solutions. And also all the technologies that are at place here, you can replicate in your own hardware. Let's say for us, it was an overkill. All this stuff, it's around 500 euros. And for our solution, so getting started. To the AP, and this is why the screen sharing will die. This will show when put into the power an AP, an access point. And that will show for something like 10 minutes after you start it. And we'll connect to that, and I will show you a bit from the setup experience. They're using this nice term. So you get the name of the box, you cannot change it. Connect, of course, screen sharing will die. It's pretty stranger.
Don't you need to connect now the module to the Wi-Fi?
Now we are connected now to the module's Wi-Fi.
Yes.
So
and
this
then
page,
set
this
up the Wi-Fi connection to.
we were saying to the module that you need to use this external Wi-Fi.
Mhm.
So thank you.
We also have a similar tool in our yard for the air quality.
Yes, something like this, something like cameras. This is the same approach. And this is, okay. I won't, let's say that it's okay. What will be the next page? The next page is how do you set a SSH connection. Ask you for a password. Because sometimes you need to connect by cable to the modem to do module to do something. And the last one, you need to set up an IoT hub. This is going around IoT hub, and we are gonna see it at work. So let it be. Oh, it's still working. Let's pick the tin, this one, and let's do a next. And again, as if you are playing with this is if you're getting the IP and all the stuff, it's everything hunky-dory. It's working. And that will do the next step. Okay, license agreement. This I forgot. And here is the step. After you have done it once, you can just pass away. And here you set up the IoT hub. Here we're going to stop. It's just a simple operation. Just say resource group, the IoT hub, and they can create everything from here. A question, what's a resource group? Resource group in your own words for a chocolate. Resource group in Azure.
Group of devices, virtual machines, let's say, networks.
Yeah, it's logical or it's physical. Logical.
And I think even paper resource group. You have the payment split by
yeah, because this is a logical. What's the point of having it? It's to be able to track your resources. If you want to delete or if you want to see them by project, this is how you should do. Where is the tin? This one. So connect automatically. We see they are connected. This is our device. So let's see what we can see here. So we see this is the general. We're talking about the Mariner, the DK. We see in the version. We're having the version module, which is this one, and we're having the speech module, this one. We're gonna play around the vision, but not now. We'll finish the story. So let's open device and IoT hub. Anyhow, how many containers we'll see? More than 3, more than 4, more than 6? Any bets? Now, put in here. Come on. The internet, it's... Okay, so how many containers?
More than 3.
Okay, more than 3. You got your chocolates.
So the module.
So the modules are the containers that are running. At least 3 you need to have. You need the edge agent, the hub, and I do not know which one. I believe two. And the rest are a couple of them are to run these components, and 1 or 2 will be the payload. For you, it's transparent. You are looking here when you're having problems, because you'll see the exit codes and stuff like this. Yeah. And let's try to dispense another chocolate. Again, going to the IoT Azure Percept IoT Hub. Come on, or to dashboard. The internet is a bit on the slow side. Come on. Okay, on this one. If you're not quite familiar with what's Microsoft offering, this is the heart of their offering if you are planning to do everything by yourself. If you do not care, if you just want to make a rapid solution, it's IoT Central. Okay, here we are having devices, IoT Edge, updates, queries. Where do I find my percent for chocolate? Devices? Who is for devices? Okay. Yeah. IoT Edge. Because this is you expect to find it on devices, and there you find the usual devices, and it's nothing. But on the IoT Edge, you will see them. Also, what you see below, and we're not gonna take you see 200 OK. You have it module count, it's 8, and deployment count, it's another story, but we'll never have the time to touch it now. Also, what we can here do, you can do updates over there. You can do everything and anything. So you do not need to, let's say in my case, take a hard hat and go up the ladder and do update with the cable. No, I can do it from here. That's a pretty long story. But getting back, okay, this is version 1. And Microsoft said, okay, it's pretty difficult to work. You need the hardware. You cannot work without it. And our samples are sheet. We will get back to that. Yeah, because, okay, for when I started this presentation, my example was people count. And I spent a good part of the month trying to make it work. And I'll show you what remains of that sample. Because I said, okay, it's too complex, we screw it up, let it be. So I said, okay, and also we are, let's say, software company, do not understand hardware. Here we have only 2 cameras, OpenVINO, this is running OpenVINO, as you know. And I can show you, you have documentation how to write with OpenVINO on top of it. Something like here. Not be. Yeah, this one. You have documentation. I said, okay, everything, it's, let's try to do it differently. So their solution was, let's partner with NVIDIA. They have also their chip for doing stuff. But their chip, I'm having a mental block, can work with 20 cameras. One. Okay, what is the issue with this? The issue is that this will be a very heavy edge. So this is the edge device. The dimension is 1 U, and it's half a server. And it's half the power consumption of the server. This is a heavy edge. Okay, ask yourself, look, we have this device in a park in 1 U. And this is taking like something like 40 watts. This is taking something like 250 watts. And this is the real server. Okay, ask yourself, what's the scenario? The scenario is a ship or a construction yard. You are having 20 cameras, and you want to see that everybody is in the safe station. Of course, we have hard hats. Or you have a huge farm, and you have cameras, and you want to see that. They want to capture this scenario. For this, okay, what's the catch with this? Why am I telling you this? This is everything announced. The fun part will be that you can try this without having the hardware. Because at the end of the day, it's containers. They will have a simulator of some which you connect your stream, and you can. It's announced. I'm hoping. Do not quote me at this. I do not know anyhow. Even if I know being the NDA information, I'm hoping that at the build there will be a public announcement. Anyhow, public, they will let it run on the field. Okay, what's running on top of it? It's running Azure HCA, and that is some version of Windows Server. It's not Azure Stack. Azure Stack, what it is? Okay, keep it forever. Azure Stack is something that you can run Azure on your server, on your data center. You run like everything Azure. There are some scenarios for this. Microsoft is trying to entice some heavy customers with the opportunity to run public cloud privately in your corner or something, in your data center. And this is Azure Stack. It's not. On this, it's running Azure Stack HCI, which is a version of Windows Server. Still, as a story, if you are really interested, the containers will always be Linux. Because they are smaller, there are some issues, and the containers running the stuff on any percept will be Linux. So let's see. Okay, Open Vinyl. This is the famous example of counting people. You see it, it's very good. So that here will most probably, if they announce it, will be the announcement. But we'll see it. And okay, they have documentation which is pretty good. But let's get back to the Azure Percept. Let's go on the Azure Percept Studio, and we'll spend the last showing demos. So, if I'm always lost here, let's go from overview. If you are going sample application, view sample applications. I'm really pissed by this. Okay. So here you have it, people count. And if you try it, which I do not suggest, you will need to re-put all the modules on the Azure Percept because it breaks. There is an issue. Vision on the edge. Still, we're talking about demos. What I'm going to show you. So, try out sample vision. So let's see if we're lucky today. And there is a problem if I'm trying to show something. For showing, I need to be in the same physical network. So if this Wi-Fi is smarter than it should be, we won't see the stream. So let's try what. In fact, let's start with continue it from the older sample. Vehicle detection. So let's see if we're lucky. Have web stream. Have web stream. And let's try to show some cars to the model and see what's happening. Just a second. And this is why I'm so hipster that I need 2 laptops. Unfortunately, it's the work one and always got. If we show him a car today, it's still low model, unfortunately. No, it's low. Any sharing, we can try it. Let's say my mobile phone, but still it's low. It's not good. Let's try now and see what's. No, still thinking. Okay, we get it, and because we need to do this eventually, or we'll take our time. So this is absolutely for debug. You know, this is also helping you. Here we see the quadrants with the yes, and let's see web stream video. You see the car. Yeah, you see it. You see that it has a percentage. 1,052. And let's move back to another picture. So you see, it's a bit of working. Again, I'm telling you what you need. This model does not have number plate recognition. But it you see, it's also fast. Okay, the comparison it's not nice because on the open Wino also we have the deployment to the stick. Here the model, it's already there. So well, we are good on it. So also you can use this camera to get pictures. Now I'll show you because time and I really like better this custom vision. This is you can run almost any models, but this is the way I like it. I like it also on projects do not targeting Microsoft. So let's see if we we have this is a model for the park. We needed to see what are the problems with the leaves. Okay, what you need to do, you add pictures, but when you add a picture, I do not have any pictures on desktop, but let's try. In fact, I have one. So let's add images. Oh, let's add myself. These are my pictures for conferences because they ask me. Here you need to say what it is. This is the classification. This is a better tool than the custom one. The custom one is for label image. And you are saying for each image what's in the picture. For example, it's a rose. It's a rose without water and stuff like this. And when you put all your pictures, you train your model, and afterwards, you are in the same account, you have it available for your percent. And this is the heavy work you need to do. Okay, getting back, but still, okay. Let's try another model. Okay, try sample vision model. Still in good time. Let's try people detection. Because there are people. Let's see what to see. Again, we view stream. I must emphasize this is for debug. So it seems that I see a lot of people. But okay, this is for debug. Yeah, the model. How do I use this? Yeah, how do I use it? Okay, I am having here a nice picture. How do I take an action? If I'm creating a model for number plates which are approved for this part. Yes, I will get the people. Yeah, I will hire you to look at them, and if they get them to open the barrier, or I'm having a good Linux IoT program. In fact, a good programmer, containers, and tries the information from the containers. No? Any ideas? That time. And we still have chocolates. Any ideas? First idea. Okay, I forgot some good work. Thank you.
For the parking to just not open the very
But how? How?
The list of the cars that are.
Still how? When I will the list, I'll have the pictures. And I will train. Okay, I will have all the pictures. I will train the model, I will run it. But still, if I'm having these percentages. Okay.
Is there some kind of console or something?
Let's get into the next chapter. So, if we remember the story about IoT in the Microsoft world, it revolves around you it's IoT Hub. So this is sending all this data there. So let's see it and let this model run. So let's go to the hub we've seen before. This is Percept. I'm always having too many tabs. So it's getting sent to here. You'll see it somehow. Just to load this blade. Yeah, it's sending some messages. Read messages, but still, that could be anything and everything. And you should never trust a Romanian. Actually buying a second-hand BMW. So let's see what's up. What will be to see what they are sending? The lazy man, the Romanian solution to show you that. The first idea. Yeah, but we do not see what's inside. Okay. No, here I do not see what's inside. Let's try in the. Let's see. And again, I'm trying you to make you remember this, not to. Give a chocolate. It's not in the. It's in the message, but you need to see the message. And the lazy man idea to see inspect messages. Yeah, it can do it. You can do it in 1001 way. You can do also query, and to send it to an service bus or something. But I'm lazy. So my idea was to use stream analytics. So I put stream analytics up afterwards. And let's see the messages. Stream analytics. I forgot to put the stream analytics jobs. Percept stream analytics. So what's stream analytics? Unfortunately, I'm very old. So for me, the analogy of telephone switchboard is fresh. But most of you have no idea what's a rotary phone. So this is stream analytics. Stream analytics is a system that can send data according to what's inside. It's governed by query and so on and so forth. Here, I did not create the query. I just put the Percept IoT Hub as input because they have a debug, let's say, functionality for queries. And let's see it. So they are getting a preview here. We will see it up and running. And that is one idea. Here we can create a query, and depending on what, and also we can specify the percentage. Usually, so what is over 0.8, it's okay. Below, it's noise. So we see the data here, but again, you are more smarter than I am. But let's try to make this. You won't see in that text that much. So let's try to select it and put it into, we have it here, new. So this is live from the model. Here they give you, send us a message, is the box, the label, because in the model you can specify for a picture. I'm a rose and I'm a person. You can specify them both. You specify that in that box, I have the label person, the confidence is 68%. Unfortunately, it seems that it's so mean. No, for me it would be 0.2. So here you find this is how the Percept is sending you to the IoT Hub what he recognizes. And one idea is using stream analytics. You can filter the label and send it to a service bus, to a function, and do some operation back. This is what we do. When we see that our roses are dying, we are sending a notification to the people who are taking care of the park and saying your roses are dying. And as one funny, we had a huge problem finding pictures of diseases of the plants. And the question for you, 420, for which plant you believe you found the most pictures? From where do you know? And I've seen you laughing. So you know what it's all about. Yes, and unfortunately, this is an European project. So I can show you, they look over the pictures and I believe that custom vision. Look. So for that, we have all the diseases in more than one, unfortunately. For normal plants, nobody had taken care of doing this.
That means that people that plant marijuana are more computer knowledgeable.
Yeah,
They know how to use the internet.
if you're looking on the internet, you find a lot of automatic culture. How do you culture in your closet marijuana? How to have lights night and day,
Yeah.
and stuff like this. And also, it's as far as I gather, it's a huge industry.
Yeah, because my mother wouldn't use Google to know how to plant.
Yeah, they use Google. Okay, was let's say just a couple of pictures. Let me look at the list. What else I need to cover? So we are in the last 5 minutes. We're still on. So to try to do a smart and short recap. Percept is the software and hardware offering. What's the role on the edge? What's the advantage? You do not need to send back the pictures to the cloud to get an answer. Now you're just sending the numbers, the probabilities. And it's very fast. You see, for all, it's only configuration. So again, this Spark project, when I got into this, more than 3/4 of the time of the project and 3/4 of the budget was spent already, and we don't have the solution. We did all the rest using Microsoft stuff in 2 months. Okay, the hardware is pretty expensive, but you can build your hardware. Yeah, so the idea is always run on the in the cloud. If I'm training here, I can pick how much it takes. Even for this, it's half an hour. And now we're having 3,000 pictures, 2 hours and a half. And the model is not big. It's in, I believe, 200 bytes. It's not that takes a lot to deploy. It's for me. I can show you also how to deploy a model. It's just 3 clicks. We just to connect to computer vision and say I want this model. Oh, have it open. Still. So I believe that here it is. I'm absolutely lost on this part. Create. And when I'm creating this, so this is on Stara Custom Vision. This is how I connect it. It's not that, I have the step from here. So if I'm doing the connection here, I will get the model back here. And this will send me automatically the percentages, and you see the output into the IT now. And there are the intelligence. The intelligence is to send something. Okay. The entry level, because for this you need hardware, not so hardware was version restricted. Funny how when we bought, we saw the instructions are also in very strange languages, like Romanian and okay. I do not want to get kicked out. Okay. It's not a strange language. But this one, when I was bought, it has only English, not even French. But the next one had no languages. These are built by Azure, but these are development kits. Okay, it's an entry level. The second version will be something like a server that you will have an emulator in the cloud. So you can try it without. Again, you see, it's not atomic science. You just play a bit in the cloud. You ask yourself, okay, cloud, I need to pay? No. In the worst case, and okay, Bulgaria is a more civilized country than Romania. I don't believe that even you need to show a credit card. Because in some countries you need to show a credit card and they take and give you back $1 or €1 to validate the card. They do not take money. And you have 1 month or $200, euros of playing around, whatever runs first. You can try. Yes.
How much does this one cost? Because I have a database in Azure that
No, it's
Runs-
not database. Database is
the
expensive.
$200
Database is
for
expensive. This is.
today.
Well, we can look in. No, I cannot do this. These are sponsored by Microsoft, and I do not have it, but it's not it. This account. On the business account, the database, I'll say for the park, we're running under $300 per, but we have Azure DevOps to 10 people. So that's expensive. We have a database, and with the database, something like 150. You get Azure DevOps, you see that this is peanuts. And also custom vision is still free. As it goes, if you do not specify very training is required. So it's something you can try. Yes, it's expensive. Maggie should not hear you because he would.
She's in Norway.
Yeah, no. So, and you'll have an emulator. Not even, but I'm really hoping that you will have build. And pretty much this is rounding up. Time to question. No question.
Where did you get the setup from? This setup, where did you get it?
You can buy it from Microsoft or from us.
And it has already pre-installed something.
Your
hardware.
I'll say it has the stuff with access point. So I show you that you get it
Yes.
from the box. You have it, depends. You can buy, I believe, these two and this one separately before you can buy them all together.
Do you need the third one, the left one?
Yeah, I'll tell you what. We have another project with our insect traps. So we need to recognize the insects. First, we kill them, and we created the model, some model, because they sound different. So it increased the accuracy model. This has 4 microphones. Again, the same stuff. We create the model, push it. We see but we them together. So it was lower. But we find the problem is they do.
You have already a Wi-Fi. You
Uh,
might not want to buy a camera.
That camera is too verify camera. It's with magnet. And it's too smart. You will have too many pixels. You like something like this. You can read to get, but you like a stupid camera, a cheap one. And also bear in mind here you have the Movidius chip, the Myriad, under this, and it's hot like hell. So here it's running OpenVINO, it's doing the inference here. So this is getting model, it's sending the model here, and here are the pictures run against the model. The OpenVINO give the probabilities and send it over. And in the new one, inside of this, it's on the server, it's the NVIDIA bigger chip who knows 20 cameras. This one knows only 2. Here you see you have a place for a second camera. And that one I said, you're going for a construction yard for a ship. And that's pretty much. And this you find on the site of Microsoft and also on the site of Asus. You see Asus. But I've seen it that somehow they are deprecating stuff. There is an issue with updating. You need to have the old, the update stuff. This I can show you, and then I will slowly wind up. I can show you where it shows, where it is. Note Percept. Let's say in IoT Hub, when you are doing updates. You see that I created all the updates, but up there, wonderfully. Come on. It says that you should, there is an older version. So for this version of Percept, you need to use the older version. And you see, yesterday I did update everything without, just from the portal. But for one, it's a bit of the wave of deprecation. The two will come. Also, we are fighting as giving feedback to Microsoft. We are still needing this kind of small devices because I won't put a server in a park in Romania. I won't put anything scrap metal in a park in Romania, but to put a server, no, sorry. So pretty much that's that. If you have any questions, I'll be outside because otherwise I would be killed. And I want to get to Plovdiv because of course the seaside. Thank you very much. So. You got it. Thank you. And there's that.
Azure Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Our customers have been trusting us for over 150 years now. Our apps rank amongst the best banking apps, and more than 1.9 million customers are already using our apps on a daily basis. We have big plans and want to extend our feature stack. What can you expect if you join our digital banking solutions team? A highly motivated agile team setup, a balanced mixture of talents and professionals, a collaborative environment with colleagues of 40 different nationalities in 4 locations, a scalable and modern technology stack with Microsoft Azure and Google Cloud Services, a flexible API-based ecosystem, CI/CD with up to 30 releases per year. We want to grow together with you. Check out our latest job postings.
Когато кажеш. Пуснало ли си? Hello everybody, my name is Andrei and I would like to welcome you to this year's Microsoft Azure Bootcamp here in Sofia, Bulgaria. First, of course, I would like to say a big thank you to our sponsors and partners who are helping us a lot to be able to run this event. And today I would like to talk about how we can use the cloud and Azure to modernize the workload of existing line of business applications. When I'm saying line of business applications, I'm meaning the normal old-fashioned style desktop applications, not some kind of web applications, which obviously can run in the clouds a little easier than the normal desktop applications. A few words about me. Here are my contacts in case you want to reach me to have some questions asked or just to say hi. Please do not hesitate. I will try to respond to every one of you. Today, we will say a few words about what a typical line of business application looks like. What's that? Can we read it or not? How we can migrate the different parts of this application to the cloud, what options do we have? And my point, my goal here is not just to give you a list of services. Какво не излиза? Okay, yes. Is it okay now? So it must be like this. So sorry, I forgot to share my screen. So I will return again to show you this list because this is the important one. Again, to see our sponsors, the people and the companies that are responsible for making this event happen. So again, we will speak about what a typical line of application looks like, how we can migrate the different parts of these applications to the cloud. And my goal is not only to give you a list of services and options, what you can do, but also to explain the things that are, at least there was difficult for us to understand, like what this will cost me, what kind of licenses do I need to be able to run that or to do that. So I will not focus only on the deployment and spinning up services and stuff like that. And I will take the opportunity also to point out few important concepts and terms which some beginners in the Azure and in the cloud may not be very aware of or may not fully understand. So I will use this opportunity to help the beginners to jump into that. So what a typical line of business application looks like. Most of the times, these are so-called three-tier applications. We have, under everything of that, a database that obviously is used to store our data. As a typical example, in Microsoft Word, this could be, let's say, SQL Server on-premise. Application server tier, for the web applications, this could be some backend, some services, or for the other type of applications, this could be some API that is consumed by the client tier. In our case, so what we will see today is I will talk about our experience with a real line of business application that we deployed in the cloud, and currently we have production deployments of that. So I will talk about our experience and findings that I had during the whole process. So in our case, the application server is just a normal Windows service application without any UI, which you can install and run on a Windows server or even on a Windows desktop. So it doesn't actually require any server infrastructure. It's a normal Windows service application. And our client is a Windows desktop application written in .NET using Windows Presentation Foundation, but these details are not that relevant. The idea is that it's a normal Windows application. It's not a web application. So someone will say that when we need to migrate this to the cloud, then we should, how to say, rewrite our start from scratch, use app service, use a web app to deploy the client here, and so on and so on. But our idea was not to rewrite our application. Our idea was to be able to modernize our workload, to be able to onboard customers, small shops without a local IT infrastructure. They don't have services on premise. And also to be able for us to provide our application as a software as a service, for example, for a monthly fee or on subscription based. So the user don't need to install anything on their computer, for example, to be able to use the application, or at least they don't need to install the application itself. The other side of the motivation was that since this application is a Windows application, we, for example, cannot provide meaningful application and user experience to the people who use MacBooks, for example, or Linux. In our case, we had this in mind for many years, but when the first time a customer came, bought our application, and said, "Oh, and by the way, we're using MacBooks. Is it a problem?" This motivated us to step in and finally do the final step and make these deployments and so on. So I will show you how we can migrate each of these three layers, what options Azure providing us, what it costs us, what are the different prices and offerings that we can use, and so on. So let's start with the database tier. There are a lot of database offerings in Azure. In our case, we are using SQL Server. So I will focus mostly on the SQL Server and compatible offerings from Azure. Of course, the most straightforward way is just to spin up a virtual machine, install SQL Server there, attach your databases, and start. Of course, it's an option. Some people do that. But Azure is providing also few different options. The most basic one is Azure SQL Database, which is how to say, you can deploy your database there, and Microsoft is taking care to managing the server. So you are free to get rid of all the thoughts about how to make backups. Do I need to do something with the TempDB or MasterDB? So in this case, the SQL Server itself is completely hidden for you. Microsoft is taking care to manage that. All you have is your database, and you focus on the data and optimizing the database, like creating indexes, stuff like that. But you don't need to care about making backups, configuring the server itself, and so on. For small applications, for small shops, this is a nice option. But for some bigger deployments and companies, they may not like, for example, the idea that they don't have access to the SQL Server itself. In these cases, they may be more interested in the other options for Azure SQL Managed Instance. Maggie tell you more about this. But the idea is that here you have more bigger access to the SQL Server itself. So it's more like SQL Server on premise comparing to Azure SQL Database. But it depends on what you need. So if you only need to store your data, managed instance may be just an overkill. And for example, when you are purchasing SQL database or SQL managed instance, there are different ways to purchase these services and to pay for that. I will show you later in the pricing, but for Azure SQL database, the two different types that you can buy is either licensing through vCore model, to purchase it through vCore model, or through DTU units. This is DTU is like data throughput units or something like that, the abbreviation. But the idea is that with vCore, you are buying number of cores. You can fine-tune the resources that are needed for your database, like compute and memory and so on. Also add as much storage as you need. And you have different prices for that. With DTU model, you have a fixed monthly price for a number of resources, but they can vary. So it's not exactly that you get one core or 5 gigabytes of memory or this throughput or so on. These measures are combined into some DTUs, so-called units, and you will be throttled on some level. So you can buy 5 DTUs, 10 DTUs, or 20, and when you reach this level of workload, you will be throttled for a while. So the performance of the database will vary depending how many DTUs you are buying. So these are the options for the databases. So what this will cost us? For example, when you purchase SQL database through vCore model, you're buying a number of vCores. So for example, the minimum is to buy 2 vCores or virtual cores, CPUs, compute power, with this amount, 10 gigabytes of RAM. And this starts from almost 400 United States dollar per month. Speaking on that, you can attach as many storage as you need to this, and you pay it in additionally. But generally speaking, the storage itself is cheap in Azure. So comparing to these $400, the storage, for example, 5 gigabytes will cost you less than $1 per month. So a terabyte will cost you how many? Still way less than the compute power of the database. Again, I said I will explain some of the terms that we're using. For example, here, LRS. What does this mean? This is locally redundant storage. On contrary, you have zone redundant storage and you have global redundant storage. So local redundant storage means that the data itself is saved in one place, in one zone. I will speak about the zones a little later, but on 3 different hard drives. So you have 3 copies of the data in one data center. This is local redundant storage. This is the basic pricing level that you pay. If you want more reliable storage, you can go up for a zone redundant storage. So the data in this case will be saved into multiple zones in the same data center. So zones are zone-enabled both Azure regions are like you can think of separate data centers on the same place or very close. They are connected to a high-speed network with very low latency. If I am correct, if I remember correctly, Microsoft guarantees that the latency between 2 zones in the same data center is less than 2 milliseconds. So they are really close. But you can think of the zones as a separate data centers. Each of them has its own power supply, network, connectivity, everything. So they are a bit resilient to local failures. If one zone is down, the rest of the zones, and there are at least 3, will take the load from the first zone that is down. So if you go for zone redundant storage, the price because the data will be saved on two different. But in case the whole zone is down, which is a rare condition, but still happens, you will be able to access your data. And global redundant storage, in this case, the data is replicated to a different region. So still the region has its own pair. For example, let's say the Netherlands, so this is West Europe, is paired with North Europe, which is in Ireland. So these are two data centers, two regions still close to each other, and the data will replicate through the internet or to dedicated connection between these data centers. So you'll be still able to access your data if the whole region is down, which is something really bad to happen. But in this case, you pay for the storage in the other zone, for the storage in the other data center, the other region, also for the network traffic. But it depends on what you need. So these are the abbreviations that you will often find. So for managed instance, the vCore model is offered with two vCores only as a SQL Server database. But if you want to have managed instance, the minimum is 4 vCores, or this is twice the price. So the pricing level will start to getting a little higher. So we're speaking about $800 per month. So this is not something that a small shop can afford, or at least easily afford. So it depends on what you need. As I said, we're looking for small shop that doesn't even have on-premise infrastructure. So these costs, and keep in mind that these costs are even without our fee for the software, are a bit higher, or at least we cannot easily offer them to small shops. But if you purchase SQL database with DTUs, you can start from very different prices. Look, this is not 1,000 separator. This is a decimal dot. So it's $4.9 per month for a database. Well, now you have to ask, does this database perform, the performance, is it enough for my application? Well, you have to try that. So there are different pricing tiers. For example, 5 DTUs for $5, 10 DTUs for 15, 20 for 30. So you can scale up and down. And you have to try your workload. So Microsoft recommends basic only for development, not for production, but it, as I said, it really depends on your workload. Actually, we are using even basic in production. Let me show this. So this is, it will not be visible in the stream, but I will show you. This is the workload for a week in our actual environment. So you can see that each night there are some spikes here. This is where we have a nightly ETL process that kicks in and start filling up the data warehouse database. So these are the nightly peaks. And we have some others in time when we have noticeable load on the database. But by default, this is aggregation is max. So it's showing the maximum load for this bucket of time. And if we change that, if can something happen, but the idea is that if we change the, this is what I should, yeah, if we change the aggregation to average, then the workload doesn't look normal to have 100% CPU database. There are some tasks that the system, it's normal to have, but if you get the average workload, now you can see that even the standard 10 which costs like $15 per month, is more than enough for our application. And if we even look a bit, so I will zoom in. This the daily workload, but I will change it like this to move it back. You can set, just a moment. You can see that most of the day is performing enough, even at this price level. So here about noon, someone was very hard with our application, but during the day, so this is the start of the day and the work day, on the database, even at this level is more than enough. Let's go on the next slide to see. So my point is that if the application is not so big, not so demanding, say to make app service, but this means that we need to rewrite our code, and we don't want to do that. So the easiest way is just to spin up a virtual machine. And virtual machines are something that can give you compute resources in Azure. You can select what kind of operating system do you want. Microsoft is offering Windows, Ubuntu, Red Hat, and various different operating systems depending on your workload. You can get images which includes SQL Server by default, Microsoft Office, or Oracle or SAP or different products. So I would like to mention a few things about virtual machines that people should be aware of when they think. So virtual machines are offered as predefined, configurations. So if you have locally installed VirtualBox Hyper-V or some kind of hypervisor, you can select how many number of cores you want, how big memory, and so on. Here you can have only the predefined configurations. But depending on your workload, is it more memory intensive or it's more CPU compute demanding? There are different series of virtual machines. So for example, if you need to run a compute heavy workload, you can go to compute optimized virtual machines, which will start with F letter. Memory optimized, for example, are giving you more memory than the normal general purpose virtual machines. So for example, there are layers on the next slide. B2S, B means it's a general purpose machine with 2 cores, and S letter means that you can attach premium SSD hard drive to it. I will speak about that in a moment. And you can have the same B2S, but with M. M means that it's memory optimized. So with the same two CPUs, in the normal, you will get 4 gigabytes of RAM. With the memory optimized, you have the double RAM, 8 gigabytes of RAM. So depending on your requirements, you can choose from different pricing configurations. And of course, you can buy more CPUs, more memory, up to, let's say, thousands and thousands dollars per month. But the most cheap, useful, how to say, computer virtual machine, which of course with 4 gigabytes of RAM, you can install Windows on it, run an application. Okay, it will not be the fastest, but it is the cheapest. And if it is work for you, you can get it for $36 per month. Add to that $15 for the database, and for $50 a month, you have a cloud deployment for your server layer. And when you are, let's go back one slide. First, I would like to mention that this is something that are not well known. You have a limit of 20 virtual machines per subscription. So think of that when you are thinking and designing your deployment model. You can rise this limit by filing a support ticket, but you just have to be aware of that limitation. And in general, keep in mind that all inefficiencies in your design when you are working with the cloud are directly related to your credit card bills. So any inefficiency will increase your cost. Well, it's not the same with the local deployments. Virtual machines will have a hard drive for the operating system. This is the image that you will get. And usually also they will get something like a second hard drive for temporary storage. While the normal hard is located somewhere in the Azure's infrastructure for storage, the temporary storage is a hard drive that is located on the same physical host where your virtual machine is running. So it's closed. So it's you can compare that like if the C drive for the OS disk is a network attached storage in your LAN, the temporary storage is a hard drive inside your server. So you can use that as a really fast storage, local storage. Normally, it's twice the size of the RAM of the computer, and the virtual, the swap file, virtual memory is going there. You can extend the storage of your virtual machines by adding data disks, so-called data disks. Of course, it's optional. You can have C drive, you can have D drive, which is the temporary storage. And if you want, you can add one or more disk drives. So you can install some software, make some data available there. It depends on you. The other important thing of the virtual machine is the network interface. So obviously, having a virtual machine in the cloud without any networking communication abilities is not very useful. However, you have a choice. You can leave this network interface only with a private IP address. So in this case, the virtual machine will be accessible only for the infrastructure, other virtual machines, services, and databases in Azure. Or you can put a public IP address to this machine, and it will be accessible through internet. But it's optional. So my point is that you can leave a virtual machine without any public IP address, which is a quite secure solution. About the disk drives, so we have data disk, as I said, which are different types. So we have standard hard disk drives, which is these magnetic spinet drives. However, look, they're cheap. You can have 32 gigabytes for a price of an ice cream per month. So how big your application is? Our is less than a gigabyte. If we want to install that, we could have it for $1. And if this hard drive is not fast enough for you, you can go for a SSD, which is still, again, $2.5 per month. And so the difference between standard hard disk and standard SSD, well, the other is SSD, so it depends on your workload. The hard drives will give you big bandwidth, but only for sequential reads and writes. SSD is obviously better than hard drives for random I/O. And since all of us have SSDs in our laptops, usually we will go to SSD. SSD will limit you to some operations per second, but it supports kind of bursting. So for light workloads, it will give you more for a while. And if you want to have more bursting, so to get better performance, you can go for premium SSD, where you can buy even more bursting. So you can pay on top of the storage, you can pay for I/O. And if you really, really, really need very fast I/O, you can go to the highest tier, which is the Ultra disks. But look the price. Now we are speaking about hundreds of dollars. And this is the breakdown of the costs. The storage itself, it's still very cheap. But with Ultra disks, you are paying for throughput. And we're talking about gigabytes per second. So I believe currently the level is up to 4 gigabytes per second. But that's really expensive. But just be aware of the options that you have. And again, this is our application server, the workload on our application server for a month. And we are speaking about 2 cores, 4 gigabytes of RAM machine, which costs $30 per month. Okay. The goal of our session is to talk more about the third layer, the client layer. Of course, we can spin up a virtual machine in Azure, install Windows on it, install our application, put a public IP address, and let everyone to use remote desktop connection to connect to it and run the application. However, this is a poor man's solution. It's not very elegant. What else we can do? Azure is offering one very interesting service, which is called Azure Virtual Desktop. So maybe some of you familiar with other services like that. For example, Citrix is very popular virtual desktop infrastructure. This is the Microsoft counterpart of this. Maybe some of you may know it from the on-premise time as terminal servers, remote desktop services, so 5 different names. And even in Azure, it was used to be named Windows Virtual Desktop until a year ago or something. So if you see Windows Virtual Desktop, it's the same thing, but the article is old. One thing that we can do with that is that we can create a full virtualized desktop environment which runs completely in Azure. So when we start the application, it will not be running on my laptop, but it will be running on the cloud. Only the window will be transferred and I will see it. My keystrokes and mouse moves will be transferred to the cloud, and the application itself will run entirely in the cloud. You don't need to install the applications locally. This means that we can run our Windows application in this service and let our Mac users, or even if you want from your iPad, or if you are, willing enough to use it even from your iPhone or Android phone, but it will not be a very pleasant experience. Of course, this service also allows you some scaling capabilities. It can even auto-scale up and down depending on the workload of your application. And keep in mind that this is something that is recently new. It's not very mature, this service. And a lot of the documentation is, how to say, a bit vague and not fully covering everything. You still see articles in internet that are controversial. One of the problems that I often had was that they're claiming that you need to have Active Directory to be able to run that, which is not true for more than 1 year. But still, for example, you'll see articles like that. What is the Azure Virtual Desktop? Let's see it this way. Everything's clear, I hope, from this huge diagram. I will try to simplify it with one more example, again from Azure, from Microsoft documentation. But the goal is that you have something that is called host pool, this part, the host pool. You have a pool of virtual machines, which is this part down there, or at least one, of course, but they can be more, which will run your application. Okay, application, so we have this published application. To be able to run this application, we have to publish it. We're publishing the applications in so-called applications groups, and we can give rights on these application groups, who can see them or who can not. So, for example, if we have 2 users, one of them, which is the administrator, can see 2 applications that are deployed to the virtual desktop, and the other one will see only one of the applications. We can do that by splitting these 2 applications into 2 separate application groups and give respective rights to the users, which are part of Azure Active Directory in this case. And all these application groups and applications are published or grouped in so-called workspace. And these workspaces are what we give to users to deployments. So this is the workspaces are what we see there. And enough talking. Let's go and get dirty. Okay, so what we need to do to get this up and running? Azure Virtual Desktop. Here it is, the service. How much time I have? Okay, not so much. We can create a host pool. As we said, the host pool is the pool of virtual machines. So, of course, some things like resource groups, host pool names, and so on, where it is located. The important part is that, so the host pool type can be either personalized, personal, or pooled. So if it is personal, depending on the user who is connecting, he will be redirected to respective virtual machine. So user A will connect to virtual machine 1, user B will always connect to virtual machine B. So in this case, they will have something like their own computers, virtual machines, desktops, call it. With pooled, you have a pool of virtual machines that are responsible to providing workload for your users. So depending on the scaling and some other configuration, the user will be redirected to some of the virtual machines from this pool. So pooled is more interesting and more usable for us. And here we can say how to distribute the users between the virtual machines. So let's say horizontally or vertically, to fill up to, let's say, 5 users on this virtual machine, and the 6th one will connect to the 2nd virtual machines, the 11th one will connect to the 3rd, and so on and so on. Or the first one will connect to the 1st, the 2nd to the 2nd, and so on until we have users connected on all virtual machines, and then the next user will connect to the first one again, and so on and so on. So let's say that will go this way. Yeah, let's say 5. Here we can select and add the virtual machine. So we can add the virtual machines later to the pool, but here we can select and create them on the fly. We have some prefix. So the Azure Virtual Desktop will take care of creating these virtual machines for us. Here we will say configure only the template. So each virtual machine the name of the virtual machine will start with something, and it will add a suffix 0, 1, 2, 3, and so on at the end. Here we can say if we want to have a different availabilities. So to configure a availability set. When we define that, we can tell Azure these 3 virtual machines are running the same, but please don't restart all of them at once. Do that one, let's say. So in this case, at least 2 will be always available, while the third one is patching, for example, or something like that. If it is zone, for example, we can select in which zone of this data center region we want to deliver that. So, for example, you can split the virtual machines. These are in first zone, these are in second zone, the rest are in the third zone. So in case one of the zones is going down, it's at least something will be available for us. The security type, of course, you can go to some trusted launch in case you are running banking software to defend better against the rootkits, firmware viruses, stuff like that. But normally you can go with standard. You can provide a image for your operating system, or you can choose from the gallery of images. The interesting part that I want to show is first you have Windows Server deployment, but you have like Windows 10 or 11 enterprise multi-session. The multi-session is the interesting part that I want to emphasize. This is the normal Windows desktop, and you don't have multi-user capability for that. You can have multiple users, but not connected simultaneously. If you remote desktop to your laptop, the local session will be disconnected to be able to serve the other connection. However, this is exclusive for Azure offering from Microsoft, which will allow you first to reduce the costs because you don't have to pay for licenses for Windows Server. You don't need cows, RDP cows, and so on and so on. And the price of Windows Server is not the same as Windows Desktop. Plus, Windows Desktop has better user experience for the users. For example, they're using the same UI as they're using on their laptop. You know that the Windows Server doesn't look the same way. Also, you can have pre-compiled images which are ready, for example, including Microsoft 365, which means Microsoft Office is already installed. So it's very easy to spin up a new virtual machine like that. So now you know about the database. We can spin up that in a minute or two. We can spin up a virtual machine in, let's say, 10 more minutes. And we can spin up Azure Virtual Desktop with Microsoft Office and Windows installed also in 15 minutes. So in less than 1 hour, you can have a completely new deployment running in Azure, available to onboard a new customer that is still speaking with the accounting department, for example, about their invoices. So this is the good thing about Microsoft Azure Virtual Desktop. Of course, later you can select some networking configuration, providing usernames and password for administrator. And the important thing here is that you can choose Active Directory or Azure Active Directory. So you have a pool of virtual machines and multiple users that they must be able to connect to each one of these. So it's not easy to maintain user accounts on each machine and so on. So usually you want to have a centralized user management. This can be either Active Directory or recently Azure Active Directory. So if you go for Active Directory, this is, for example, if you have on-premise Active Directory, which is synchronized with Azure, you can go this way, so the users will use their existing AD accounts. Or you can spin up a virtual machine, install Windows Server there, and spin up your Active Directory there entirely in the cloud. Or use Azure Active Directory Services, which is a service provided by Microsoft, which you can use with Active Directory. If you go to Azure Active Directory, you have the normal Azure Active Directory that, for example, if these users are using Office 365, they already have that. And they can these virtual machines using their Azure. You can set up the workspace, for example, can these users the desktop or only the remote apps, and so on and so on. However, the deployment of this Azure Virtual Desktop will take like 15 minutes. So I will show you something that's already made. I still have a few minutes. Okay. So in this host pool, we have one virtual machine and 0 that are currently down. So the host pool has only one virtual machine. And here, for example, we have the application groups. I can create an application group from here of applications, and I can add different applications to it. Register application in 3 different ways. So I can select something from the start menu, okay, Microsoft Edge, for example, the browser, or I can tell the system the path where the file is located, for example, on a data disk that I've attached to these virtual machines. And this is the way I can register the applications. And the idea is that at the end, the user will either install something that is called remote desktop client. This is not the remote desktop connection that comes with Windows. It's something similar to the Citrix workspace, Citrix receiver, or whatever it's called. So it's an application that is installed locally. Or they can even use that and connect to this virtual machine through a modern browser. So Chrome, Edge, of course, with the Chromium engine, or the or if you are on macOS, you can use even Mozilla. But this is the list of applications that are available to me. So, for example, I will run this. I prepared a small PowerShell script just to show you that it is not running on my computer. So until it runs, I will run the same script here on my computer. So you will see on my computer, it will tell you that the name of the computer that it is running is HP, that's my computer. And the one that you see here in the browser is saying that it's in Azure Virtual Desktop VM0. So this application really runs in the cloud. And things to say, mostly about the licensing part. Not talk about availability zones anymore. We don't have time for that. But just to show you again the hardware that we use and what it will cost. We are having 6 users, and I spin up 1 virtual machines with 4 CPUs and 16, and this is our workload. So it's more than enough. And this cost me like $120 per month. including the licenses. On top of that, I need to pay for Microsoft Office 365. However, you cannot use the normal, how it's called now, premium, which is like $20 per month. Because you'll get something saying, here it is, that you cannot use this in a shared environment. So you have to pay a little bit more for a more expensive license. So I cannot use the business standard, I have to use business premium for that. Or the other option is to install Windows Server instead of Windows Desktop in our virtual machine. And in this case, I will have to, let's say, buy Microsoft Office to a volume licensing or something like that. But our idea is to be able to quickly spin up deployments for new prospects. So business premium, which costs like, I don't know, $22 user. So it's very easy to spin up these kind of environments. And one more important thing is that when you spin up this for your company, is the prices that you'll see. However, if you want to do that for your customers, so for users that are external users, not part of your organization, you have to pay a little bit more. It's called per user access pricing. So you have to pay $5.8 per user per month on top of that. Or if their users will also need to access the full desktop, in this case, the price goes for $10 per user per month. So it will be cheaper for you to convince your users to spin up the Azure Virtual Desktop in their own tenant, not in yours. You'll save a few bucks. And to enable that, when you go to Azure Virtual Desktop, there is one menu per user access pricing where you can select subscription and it will be paid. The access of the users will be charged in this subscription on top of that. So what are external and internal users? As I said, I cannot use the normal Office licenses there. You have to use something, either volume license or business premium. And Windows Server is also providing profiles. So when you log in with your Active Directory credentials, you can see your desktop. When you're running Windows Desktop in the cloud, like the normal Windows Enterprise, you cannot do that. But there is a service called FSLogic, which Microsoft provides for free, which will take care of storing and updating user profiles. So when someone is logging in on this Windows Enterprise, his profile, which is located somewhere in Azure Files or blob storage, will be downloaded and it will be attached to the virtual machine when these users log in. So you still can get these personal desktop profiles, user profiles, and so on. One more thing to say that I already told you that you can add existing virtual machines to the pool. In this case, you can go to the pool, get this registration key, and in the virtual machine, you have to download something called Azure Virtual Desktop Agent and give him this key, and the virtual machine will be added to the existing pool. So if you have this already up and running, you can change that. So about how we can access this, as I said, there is something remote desktop client software, which is available for all major operating system. You can access to the web browser itself, and some things about troubleshooting. For example, I would mention only the first thing. If you use Azure Active Directory joined virtual machines, you may get this error. We couldn't connect to the remote PC because your credentials did not work. Very helpful message. In this case, you have to say on the remote desktop connection to add one additional property that target is AAD joint. And this, you can go here in the host pool, which is here, not here. In the virtual machine, total machines, not application groups. Anyway, here in the menu, I've gave you the screenshots from here. Yes, in the properties, you can go to the virtual desktop properties. In advanced, you have one big list of properties, and you just need to add this text, target, this AAD joint, and so on. Do you have any questions which I can answer? I hope all of this will be useful for you. It's just an use case to show you how you can very quickly deploy and spin up environments, even if your software, your application is not a modern, that is, how to say, Azure native, cloud native application. So even with an old application, you can spin up that in Azure in literally less than 1 hour. Any questions? 1, 2, solved. Okay, in this case, thank you for being here today. I hope all of this has been useful for you. Thank you.
Azure Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. The ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Our customers have been trusting us for over 150 years now. Our apps rank amongst the best banking apps, and more than 1.9 million customers are already using our apps on a daily basis. We have big plans and want to extend our feature stack. What can you expect if you join our digital banking solutions team? A highly motivated, agile team setup, a balanced mixture of talents and professionals, a collaborative environment with colleagues of 40 different nationalities in 4 locations. A scalable and modern technology stack with Microsoft Azure and Google Cloud Services. A flexible API-based ecosystem. CI/CD with up to 30 releases per year. We want to grow together with you. Check out our latest job postings.
Azure Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Our customers have been trusting us for over 150 years now. Our apps rank amongst the best banking apps, and more than 1.9 million customers are already using our apps on a daily basis. We have big plans and want to extend our feature stack. What can you expect if you join our digital banking solutions team? A highly motivated agile team setup, a balanced mixture of talents and professionals, a collaborative environment with colleagues of 40 different nationalities in 4 locations, a scalable and modern technology stack with Microsoft Azure and Google Cloud Services, a flexible API-based ecosystem, CI/CD with up to 30 releases per year. We want to grow together with you. Check out our latest job postings.
Azure Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Our customers have been trusting us for over 150 years now. Our apps rank amongst the best banking apps, and more than 1.9 million customers are already using our apps on a daily basis. We have big plans and want to extend our feature stack. What can you expect if you join our digital banking solutions team? A highly motivated agile team setup, a balanced mixture of talents and professionals, a collaborative environment with colleagues of 40 different nationalities in 4 locations, a scalable and modern technology stack with Microsoft Azure and Google Cloud Services, a flexible API-based ecosystem, CI/CD with up to 30 releases per year. We want to grow together with you. Check out our latest job postings.
Azure Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Our customers have been trusting us for over 150 years now. Our apps rank
Hello, I hope everybody can hear me. So my name is Ivan Iliev. I work as a DevOps consultant, and some of my responsibilities, unfortunately for me, are also cloud architecting and cloud consultancy, as well as some cloud governance, I would say. So today I actually want to spoil it a little bit. I wanted to name this session How Not to Work in the Cloud, because for the past few years, again, unfortunately for me, I saw how customers just heard, okay, let's go to the cloud, but for one reason or another, it was not really successful for them. Um, I would like also to thank the sponsors of this event. So cloud strategy for greater performance and reduce costs in Azure. So the thing I've actually observed is that the performance or the costs are not really attributed to, let's say, the cloud provider, or let's say that Azure is more expensive or than other cloud providers, or other, even if you compare them to on-premise. However, they are attributed because somebody used to work for on-prem, where I would not get into details of the on-prem because there is a quite long tradition of how we do the things in on-prem. You have all these positions for the on-prem data center technician. You don't have this in Azure, or you as a company don't need a data center technician if you're going to work in Azure. Azure still needs this, but you don't really need it. So the agenda for today is first the cloud management. What is cloud management? How do we do it? How do we actually implement it? Do we did something wrong? Do we actually need cloud management? Later on, we'll focus on the costs in the cloud, what we actually pay in the cloud, what did we choose to pay in the cloud, and finally some useful tips I actually saw that are working for, I would say, all the customers one way or another, but it's very kind of vague. The thing is that I can speak only from my experience with specific customers. So it's really case by case. So your case might differ. That's why I'm not trying to give you something like, if you do this, you're going to be 100% successful. That never happens. So cloud management. Usually you hear from the management of your company, or a customer comes and just tells you, okay, we heard that the cloud is the future. We are just going to the cloud. And you see a bunch of managers around a table with a laptop, which is pretty sure this means, I'm pretty sure this is the cloud right here. But yeah, which cloud exactly, what, and so on, all those questions, they are left to the engineers. This lecture, actually, I'm trying to give some tips more on the engineering side, rather than project managers, POs, and so on, because usually your project manager comes and tells you, okay, we are going to the cloud, just do it. And you're on your own. Of course, there are many differences between on-prem and Azure, or I would say in general between on-premise infrastructure and infrastructure in the cloud providers. But I will focus on those 4 points. The first one is the maintenance part. So how we do actually maintenance on the on-prem. I've actually had to call data center engineers at 3 in the morning to go to the data center because the RAID controller just decided to burn out, and that server is totally not going to boot. Well, we don't have this in Azure. In Azure, actually, it really depends on the service you are using, because you have different forms of management they will provide to you, but you're definitely not going to manage the physical infrastructure, not going to data centers and so on. Another thing is the supported services. So if you worked on on-premise environment, you might actually not have seen the supported services, but you can also implement supported services, especially if you work in something like OpenStack environment. You can provide actually managed services, but you have to manage those for yourself. So even if you have them, your choice would be definitely very limited, usually between databases. So it will be something like databases service. It might be some authentication provider to implement authentications, but not much more. Well, in Azure, we have, I'm not even sure how many services exactly up to today, but they're added by monthly basis, so quite a lot, I think over 200. Also, another aspect, which is a big difference, but most people tend to think it's actually the same, it's the planning part of, let's say, a project. How do we plan for the on-prem? Well, if it's something like a POC, we cannot just go and do the POC. We need to buy actually a physical infrastructure or rent it from somebody and do a contract because he have to buy it and so on. So it's kind of complicated. We need to have a quite strict budget, and we need to plan exactly for this budget in advance and so on. Where in the cloud, it's kind of more flexible because, okay, we see this POC, it's not going really well. Probably it would not happen after a month. We have our budget, but we can just decide to stop that POC, and we'll essentially save the remaining part of our budget. For on-prem, that's not really the case because we already bought those things. We can still resell them to another company, but that would be a little bit harder. So I would say generally for the on-prem, we need to plan in advance what exactly step by step do we need, and we need to order it and so on. But in Azure, for example, you just actually are planning where do you want to actually complete your project, or because the projects never actually complete, they constantly need to develop, modernize, and so on. But you need to just follow roughly your budget. Okay, I have, let's say, $1,000 for a POC. Okay, I have this amount of money which I can spend, and I'm going to actually give you a nice little trick for this exact point in regards to budgeting and planning. Another major difference, which also combines quite a lot within itself, is the developing and architecting part. So when you develop, usually on the on-prem, you need to provision everything you need. So let's say that you work with data. Of course, you need to have some kind of a data warehouse, database, and then you want to, let's say, consume this data, learn some, not learn, but run some AI analytics on this data and so on. Then you need to actually get this entire software up and running, configure it, most likely on a virtual machines, or even if it's on containers, those containers would still be in the virtual machines you would still need to manage, and so on. And you generally avoid actually getting too many services, exactly because you will need to ensure that all of them are up and running. And if something goes down, your entire system usually goes down, and then you have to go and fix it. And that's not really good. However, in Azure, you can essentially consume quite a lot of services and don't really care about. You have much more freedom on this. On one side, it's exactly this freedom. On the other side, it's a little bit kind of trade-off because you cannot really use your open source software. You can still use it and just create a virtual machine and put it on top of it, but still that would be something that you're responsible for. So I've actually got this thing right here, exactly from the Microsoft website. It's actually an article in regards to CCUE. And if you don't know what CCUE stands for, it's Cloud Center of Excellence. So actually, not only Azure, but most of the cloud providers will suggest you that you get a CCUE team for large organization. And what CCUE does exactly, I would not get into details on all the points, but they are essentially responsible for your cloud governance, you can say. So what actually Microsoft suggests here is that we have two models, control and central responsibility, or freedom and delegated responsibility. And that very much is equal to this picture here. So on one side, we have enforce and control, which is controlled on central responsibility. On another side, we have enable and support, which is the freedom and delegated responsibility. And what they mean by delegated responsibility here, it's actually delegated responsibility to the different departments within an organization. So if you implement CCUE, at least according to Microsoft, and it's actually successful, you're going to very much look like the roundabout and not like the traffic stop. And I've seen actually customers which look like crossing the streets without any, let's say, traffic lights or roundabouts, or just without even street signs. And yeah, I would also probably note here that the control and central responsibility, it's not really that bad of a model, but it really depends on your organization. Essentially, this model provides you a way to enforce and control what exactly is being deployed, how it is being deployed, and it's very much more stricter control on what you actually do. So, do we need a cloud team? And that's in the regards of the cloud management. There is something I'm occasionally seeing, the no hard drive replacement phenomenon, which I would say comes from that, okay, I migrated all of my things into the cloud. I don't actually need a system administrator. I don't need a DevOps. I don't need a DBA. I don't need anybody. I just need a front-end developer, let's say an Angular one, and that Angular developer will do his own things, and then I probably need another developer for my backend, and it would finish until this point. But that's actually not still true, because Azure still provides certificates for not only fully development position, it would provide certificates also for system administrators, for DevOps, and so on. So if you just go and see the certifications, you would see what positions you need within your team or department and so on. Also, something else which we don't think really is the too many services. So when you have over 200 services, it's almost impossible, I would say, to have technical capabilities on 200 services. That's quite a lot. Let's say you will be able to learn how exactly a few services here and there work. If you work with databases a lot, probably you'll know the databases inside and out, but you probably would not really know what actually the AI or IoT hubs and so on actually do. Another thing here is the shared responsibility model. So if you have not heard what is the shared responsibility model, it's more on theoretical, describing what you actually manage in the cloud and what actually the cloud provider is responsible, in this case, Azure. And it very much depends on what actually service are you using. Is it infrastructure as a service? Is it a platform as a service? Or is it some kind of a software as a service? So if I have infrastructure as a service, let's say a virtual machine, and I just think, okay, Azure will manage it for me. But what they are actually going to manage for you, they are going to manage the physical infrastructure, but not actually applying your updates. Let's say if it's a Linux VM, updating your kernel, or if it's a Windows, just pushing your updates and enforcing them. You would still need to be responsible for this. You would also need to be responsible for backups. What happens if that machine goes down? I'll need to ensure that I have another machine in a separate zone or even in a separate region, and that all actually comes to me. So if I use, let's say, software as a service, then of course I would not be actually able to do these things. So it would be essentially Azure's responsibility. And I actually have a rule of thumb here. Generally, within cloud providers, if you can actually change setting or touch something, then most likely you are responsible for it. And what happens actually if you change that setting. Architecting, deploying, using. All right. So when we are architecting, deploying, or using eventually an application, we have, I would say, different concepts, problems, and so on, which we are trying to solve on a vertical line. So the first one is the technical capabilities. So in the public cloud, we both have more technical capabilities because we can just use, let's say, platform as a service. Also, we can scale and use all this software, which we don't care, and it's all provided to us for free. But eventually, also, as I mentioned, the number of services, it's quite big. So we really need to also pick the service correctly, because if we are speaking in regards to Docker containers, containers can be hosted on Azure container instances, Kubernetes, and even web apps. I think there was also another service which was for .NET, if I remember correctly. But you definitely have a lot of choices, and that's not even including the virtual machines. So you have, let's say, 5 or 6 ways of actually doing the same thing. Which one I should choose? That's up to your case, because those different services are for different use cases, and it all depends on you. Another point for the cloud, when we are architecting initially, when we are thinking, okay, how we are going to build it, which language should we choose? It's think horizontally and parallel. What that means, usually we have vertical scaling, which generally means just, let's say, provision a bigger resource type with more CPUs, more memory, and so on. And we have the horizontal scale, which is let's add one more service and to use, for example, a load balancer in front of them, or let's say they use some kind of a queue to communicate between them. Also parallel. That's really important, because no matter how do you design it vertically, you would still hit, let's say, some border where you just add more CPUs, add more memory, but it just doesn't work for you. So you have to design your application really for also parallel. And also Azure provides you really good options for this. In terms of parallel, you would generally design for, let's say, what happens if exactly this message receives an error, maybe we'll return it back to the queue, and so on for processing. Then Azure actually provides you one really cheap option, which is the Azure Spot virtual machines. And they're essentially cheap because they're unused capacity of the cloud. So when you're creating some infrastructure, you can utilize this unused capacity in the cloud, which can come as much as, they will say something like 70% cheaper than what you would pay for example, for on-demand. But essentially that capacity would come you of around, let's say, 50% cheaper. Usually it's roughly between 50%, but that comes with a downside, and that downside is actually that when this capacity is actually needed, the cloud provider will just take it. So you also need to provide resilience. Also, for application, we generally design them as either monoliths, microservices, or fairly, I would say, recently, serverless applications. And I agree there might be other cases, but roughly agree that these 3 types of applications are the most, I would say, commonly used. And the cloud it's not really designed to be for monolith applications. Yes, if you're a small company having just, let's say, a very simple website where you're, let's say, you need to just advertise your products and so on, well, monolith application on a web app might be the perfect solution for you. But then you're not really a large organization, so that fits your case perfectly fine. But if you're a little bit larger organization and you have let's say, a big office, you have one system for your finance department, which needs to communicate with your, let's say, sales department systems and so on. And let's not get into, for example, I work for a media company where they actually provide content to, I would say, millions of users. They have quite a lot of systems and quite a lot of microservices or services where they communicate between each other. And that's really easy to add into the cloud. So if you add a monolith application in the cloud, you're generally limited how it can scale, where should we go, and so on. But for microservices, generally, you're good to go. Serverless is also another good option, but that usually involves, if you already have something, to completely rewrite it, completely from the ground up. However, I've seen also combination between microservices and serverless in the same application or a system, and that generally would work. It depends really, because you can have some part of your application. Let's say that you're providing some streaming services. Of course, you would not provide your actual video streams via serverless. You will do something like services and so on, but still you would have many other things around your company, which can be on a serverless, let's say your authentication, login and register, and let's say billing and so on. Let's say if I want to pay with my card, that can go to serverless, and we can actually start little by little migrating to serverless if we really want this. But as I mentioned, monoliths, if you're really sure you need to have it as a monolith, then you can actually do it, but the cloud, it's not really designed for this. That's why we have that many services and that many ways to split them up within the cloud. So it comes to one of my favorite topics, costs in the cloud. So in terms of costs in the cloud, I actually like to say that in the cloud, you actually pay for what you create, not for what you actually use, because most of the services, you would still pay them because you kind of reserve them for other customers, and they would still be up and running regardless if you're using them or not. So if you're using auto-scaling on all these things in Azure, to scale your application when there is vault and there is none, you're in a sense good to go. But here there is a little trick that it also depends how do you exactly configure it. If you allow it to create 100 virtual machines and somebody decides to, in a sense, DDoS your website by running some specific request, and your system essentially decides, okay, I'm going to scale, and it scales to 100 machines, then you have to pay quite a big bill. It's actually not that cheap for us. Well, it's not really the case. It really depends how do you use it and what do you use. First, let's eliminate the factor that you need to have, apart from the physical infrastructure, you need to have a whole, I would say, department to actually manage this physical infrastructure, or hire external company to do this for you. You still need to pay them, and yeah. This actually came from, I would say, beginning your cloud journey somehow, because you heard, okay, let's go to the cloud, and then not actually having an idea what and how we are going to do it. We'll go just do it like we did before on the on-prem, but it doesn't happen really like this. So in the cloud, I already mentioned what do we pay for in the cloud. Also, for many services, I think somebody mentioned before, I think on the previous lection, that, for example, the databases, they have different payment options. You have the normal vCore, you also have a DTO. For let's say, virtual machines, we also have different options. We have on-demand, we have spot virtual machines, and we also have reserved virtual machines. Although reservation, it's generally a reservation of capacity, so it does not limit itself only within the boundaries of virtual machines. You can also reserve capacity if you know you're going to use this resource for the next 1 or 3 years. You can still reserve that capacity on some of the services and benefit quite a lot. And what I've noticed as well is that not many people actually buy reservations. They're kind of scared. Okay, I will buy a reservation, but I'll need to pay in advance. Then what happens if I actually need to bring this resource down and I don't need the reservation anymore, and so on. And the big factor here is that by being scared of actually spending money for reservations, you're actually losing money. And I would say quite a lot, because reservations can cut your costs quite a bit. Another thing is, did we choose the right service for the right job, and is it scaled correctly? Let's say that we give a developer to do some kind of a POC. He goes to the cloud and he's like, okay, I need to import my large dump file of, let's say, 100 gigabytes within a database, but I don't really want to be slow, so I'm gonna just create this resource extremely large. I don't even need that much resources, but then he starts kind of working, then this database with, let's say, 16 CPU, 32 RAMs, and so on, it's just left running for a POC where you actually need 2 cores and 4 RAM, or yeah. And the thing is that we generally forget to remove fully those resources. Yes, we might, let's say, after we are completed, delete big part of them, but still, usually, okay, I'll do it tomorrow, I'll do it the day after tomorrow, or next week, and so on. Then I'm going on a holiday trip, and this resource, it's just staying up and running and consuming us quite a lot of money. Also, in regards to the right service, as I mentioned, there are a number of ways of actually implementing quanting, and because of different use cases, we have different services. So let's say we have containers, and we can choose between multiple services. Which one should we choose? Let's say that we bring the container instances, but for container instances, we cannot really share the capacity, because let's say our code, it's not utilizing our compute power 100% of the time. And when it's not 100%, then we are actually paying for something we are not actually using. Fairly recently, I've noticed that we can actually use Kubernetes for some customers by utilizing this unused, in a sense, capacity, because we have, let's say, 20 containers. And at a certain point, mostly 2 or 3 of them need, let's say, some compute power. The others are either idle or they're waiting for something, but generally they're not actually consuming. So we can provision, let's say, a pool of virtual machines. We can also use spot virtual machines for some operations, and just use some labeling to tell the containers, okay, don't go there, or just go to the on-demand or reserved instances. And that's really kind of cutting your costs by actually providing you quite a bigger utilization of the resources you actually have created. So now speaking for these points, useful tips, because it's in the cloud. There are, as I mentioned in the beginning, there are quite a lot of things you can add, but it really depends how you as a company work. You, for example, might be a product company which have one large product, or you might be a company which is actually managing the products of other companies and helping them and so on, and they just want to consume it as a software. So you have, in this case, quite a large number of cases. What I found working. So one of the things which I really find useful when speaking with customers is the multi-tenant environment. What is multi-tenant environment? Usually, if we just create a subscription in Azure, we have this subscription, and we can, of course, split our resources logically by resource groups and so on. But let's say that we had a case with the customer some time ago, where actually that problem was found by a colleague of mine, who actually joins that subscription and sees one quite big number of bill. Let's say the bill was something like $50,000 a month. And he goes, okay, what do we spending money for? And he goes resource by resource and so on. And finally, he found that there was a backup solution, which was for some reason routing the traffic via an on-premise data center to do the backups and then back them up in another, actually completely separated, not connected subscription. And you can imagine something like, I think it was around $27,000 a month just for backup traffic. And that was why you should do this. The actual storage you are paying for was actually cheaper than the traffic because you're constantly doing backups of this data. And that's not really happy. And when we actually started investigating why this happened, actually it turned out that, let's say that you have a service for cost analysis in Azure. You go there, you split, how do you want per service, per resource group, and so on and so on. But usually it's not an engineer who is actually proficient in cloud who does this. It's, let's say, Katie from the finance department, who just goes to the cost analysis service and clicks, okay, I have a $50,000 bill this month, I'm gonna pay. Also, she probably doesn't really know how to split this cost to, let's say, something like tagging, or not only tagging, but let's say resource group and per service type and which exact resource from which exact department and so on. She just sees that we have a bill and we need to pay. So multi-tenant environment really helps you with this because you are able to split the multiple projects, and I would even go a little bit further, split the different environments of this project. Let's say that we have a project A. We can have actually 3 subscriptions for, let's say, dev, testing, and production. And that would also provide us with completely isolated environment for infrastructure as a code or CI/CD. Also, if something like this happens, we know exactly who is responsible for this thing. If it's on the dev environment, okay, probably somebody just went there, misconfigured something. We are going to fix it eventually, but at least you can point out straight away who is responsible for this tenant. And you should really be thinking about multi-tenant environments because they don't actually cost you anything. You just connect the multiple subscription. You can connect them with a single authentication provider. So you just click one button and decide on which subscription do you want to work if you have access rights to it. So policies, what are policies? Policies can be also implemented in Azure as a service. So you can write policies. Let's say, I don't want this resource to be provisioned above this type because I don't think anybody in the company will actually need it. So I might want to restrict this, but they can be also unwritten. For example, for this system or for all of our system, which exact type of database we are going to use. So we are going to use SQL, but should we use, let's say, SQL Server? Should we use MySQL? Should we use Postgres? And so on. We can also narrow it, so we can essentially have much more technical capabilities within a single field. Of course, if we need it for something else, we can use it. We are free to do it. but we need to have at least some policies, especially if you have multiple departments and you're just expecting them to sync between each other. How are they going to sync? Their people just naturally would not do this. Infrastructure as a code, I've already mentioned. Everything needs to be done by infrastructure as code and CI/CD, because if you go and touch things manually and so on, we forget quite a lot of things. Also, if we are going, let's say we have different stages, development, testing, production, it's kind of becomes hard to troubleshoot. So I've heard like, okay, but we should not commit to the master branch, but what we do with the hot fixes, like we should commit it directly to production. And I'm like, yeah, but why this is present on the production, but not present on the environments which are, let's say, development or staging? This problem is not there. So somebody actually went and manually changed something into production. And that actually happens quite often, I would say. You would be lucky if you work in the company which actually enforces you not to be able to push it all to the upper branches and so on. How would we actually do those things like infrastructure as a code, CI/CD, and policies? If we can, we have a project, we have a, let's say, that POC, but we have no idea how to do it. We did some research, but we don't know how it exactly would work. Then we have actually the playgrounds accounts, which I put at the bottom, but it's not really the bottom. So those playground accounts, what are they? They're essentially a subscription where you set a budget limit of, let's say, $500, and purely just your developers or we as a developer and engineers can go there and just play around and see what will work for us. And we have a limit which is $500, so we don't need to actually worry. So after we polish our solution and so on, then we can start actually writing some infrastructure as code, CI/CD, and so on. So in these accounts, you can actually do it's literally a playground for you to play. Also, small tip, if you actually worked in slightly kind of bigger company, you probably would see that many customers are actually paying Microsoft and other cloud providers have it as well for technical account managers, or essentially people who you pay them quite a large amount of money, but they will really help you. But something else you can also ask them is for credits to play with, let's say, a new service or a service you have not already implemented and actually using actively. So they will give you some amount of credits to play with different services if you have not used them before, just so you can see, is this working for me? All right, it's working. I'm gonna use it, and yeah. So don't just migrate an application to the cloud. That's quite simple. I've already mentioned. We don't need to have monoliths or migrate literally our infrastructure directly to the cloud. In some case, let's say we need to decommission a server room. Yes, okay, but we should really be thinking about how to make it more cloud native. Don't just migrate them, because this will actually play a really bad job to you. Let's say we had this system, which was on-prem, 10 virtual machines, we migrated, everything is good, but virtual machines are expensive and they will consume quite a lot of money. So if we migrate them, we'll just remove what I call the hard drive replacement. It's not really only a hard drive, it's quite a bit more money, but you will just remove one position, which is the data center technician. You'd still somebody to apply your updates to ensure I have not even got to the point of the security, to ensure your security, to ensure user management, provisioning, and so on. And finally, what we try to implement with, I think, one company is design reviews and architecture forums. What are those? So essentially, you have done your POC on a playground account. You've come up with some architecture and a design. You've also calculated your cost exactly to the point because you already know how much it will cost you. And you go to this forum where you have a team from the, let's say, security department. You have from, let's say, a cloud team. You also have somebody who is probably technical lead on the code. You've written your system and so on, and they actually need to review your application and say, okay, can we tweak, for example, here? Do we need this thing here? How probably we can do it work better, more resilient? Okay, but what happens, for example, if we don't have, let's say, a separate instances for recovery, backups, and let's say we have an outage? They are really the people who should decide, okay, this is a critical application. We need to have a separate set in another zone, in another region, and so on. So that was from me. Thank you very much. And I will leave the remaining time for some questions. Any questions? Then thank you very much. And thank you for participating in Global Azure.
Amongst the best banking apps, and more than 1.9 million customers are already using our apps on a daily basis. We have big plans and want to extend our feature stack. What can you expect if you join our digital banking solutions team? A highly motivated agile team setup, a balanced mixture of talents and professionals, a collaborative environment with colleagues of 40 different nationalities in 4 locations, a scalable and modern technology stack with Microsoft Azure and Google Cloud Services, a flexible API-based ecosystem, CI/CD with up to 30 releases per year. We want to grow together with you. Check out our latest job postings.
Azure Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. To our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Our customers have been trusting us for over 150 years now. Our apps rank amongst the best banking apps, and more than 1.9 million customers are already using our apps on a daily basis. We have big plans and want to extend our feature stack. What can you expect if you join our digital banking solutions team? A highly motivated agile team setup, a balanced mixture of talents and professionals, a collaborative environment with colleagues of 40 different nationalities in 4 locations, a scalable and modern technology stack with Microsoft Azure and Google Cloud Services, a flexible API-based ecosystem, CI/CD with up to 30 releases per year. We want to grow together with you. Check out our latest job postings.
Azure Bulgaria was founded in 2000 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Our customers have been trusting us for over 150 years now. Our apps rank amongst the best banking apps, and more than 1.9 million customers are already using our apps on a daily basis. We have big plans and want to extend our feature stack. What can you expect if you join our digital banking solutions team? A highly motivated agile team setup, a balanced mixture of talents and professionals, a collaborative environment with colleagues of 40 different nationalities, a scalable and modern stack with Microsoft Azure and Google Cloud Services, a flexible API-based ecosystem, CI/CD with up to 30 releases per year. We want to grow together with you. Check out our latest job postings.
Azure Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripes is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. We offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripes.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Our customers have been trusting us for over 150 years now. Our apps rank amongst the best banking apps, and more than 1.9 million customers are already using our apps on a daily basis. We have big plans and want to extend our feature stack. What can you expect if you join our digital banking solutions team? A highly motivated agile team setup, a balanced mixture of talents and professionals, a collaborative environment with colleagues of 40 different nationalities in 4 locations. A scalable and modern technology stack with Microsoft Azure and Google Cloud Services. A flexible API-based ecosystem. CI/CD with up to 30 releases per year. We want to grow together with you. Check out our latest job postings.
Hello, everyone. Greetings from Poland. Hopefully you can hear me and see me and my screen. It would be great if you can say so or say hello. It's my great pleasure to be with you at the Global Azure Sofia, at least remotely. Still better than not at all. Oh, everything is okay. Great. I would like to start with saying thank you very much to our sponsors, organizers, and to the audience. You are really needed to, well, without you, this kind of community events would not be possible. And I know it's a very last session scheduled for today. But hopefully you will find this session interesting. It's about applying AutoML, automated machine learning, to computer vision problems. My name is Marcin Szeliga, and yeah, I'm from Poland. I've been working with Microsoft Data Platform Technologies for almost 30 years already, starting with SQL, and a few years ago we moved to Azure. Everything has changed at that time for better, in my opinion. Right now I'm working at a university teacher and MCT, Microsoft Certified Trainer, delivering the different kind of classes related to Azure Data Platform. I know the session is, well, remote, but still, it may be interactive. It's up to you. So I strongly encourage you to ask questions, use the chat window. I'm looking right exactly for this specific reason. So do not hesitate, ask questions immediately. I will try to answer them at once. If there will be related to upcoming topics, probably I will postpone my answer. But again, try to make this session as interactive as possible. The agenda is rather simple, just 4 points, 4 topics. I'm going to start with challenges, then briefly talk about the tools, namely Azure Machine Learning Studio, the environment that I'm going to use to implement computer vision by combining 2 hopefully well-known for techniques. The first is transfer learning, and the second is AutoML. So what are those challenges? Because we know the AI or ML, machine learning, is great, and you can find practical appliances of computer vision and machine learning in general all over the place. We are using them daily for broad range of tasks. And computer vision especially is pretty popular. But it doesn't mean it's easy. Why? First, to train a deep learning model, you have to have a lot of data. And believe me, just downloading all those pictures from social media is not enough. Why? First, you have to label this data. So we are talking about supervised machine learning techniques, which means that each example, and to train a deep neural net from scratch, it requires thousands or maybe even more those examples, those pictures basically. So you have to label each one of them. And this is crucial. So you have to trust those labels. A lot of work. Then the second challenge is to train this kind of models from scratch. you will have to have a huge compute power in terms of GPUs, and the GPU memory will be needed as well. Not all of us, even if I'm talking about companies, can afford those kind of GPU powered clusters. And lastly, to train a successful model, the model that will be able to fulfill our needs, well, coding skills are needed, basically Python skills, and modeling skills are needed as well. All together is a rare combination to have all of this. But still, we would like to train our own computer vision models. How to achieve those results? Relatively easy. Well, that's the point, that's the goal of my session, to teach you how you can achieve your tasks without spending months of data preparations or thousands of dollars on compute resources and years of getting coding and modeling skills. So to achieve this, we have to have a great environment. And well, it's probably not a surprise that I'm going to use Azure Machine Learning Service. If you know this service, that's great. It's a platform as a service. You will see the interface, Azure Machine Learning Studio, shortly. And in addition, Python and R SDKs that you can use locally or in the cloud. It's up to you. Altogether, this Azure Machine Learning Service enables you to do end-to-end machine learning experiments, from data preparation and quality assessment, modeling, some model training, data enhancements, maybe even model quality assessment, deployment as well. And we are going to train our models in experiments. I did it in advance. I performed a few experiments for you. All those experiments are automatically tracked. A huge amount of data is being logged about your experiments and about those models. And finally, you can deploy those models to web services easily, as you will see. So that's our tool. We know the problems, the challenges, we know the tool, and now, again, feel free to ask questions if you want. We can start talking about, well, procedures. So first, transfer learning. Any deep neural net, so a net containing a lot of those layers, in any of those nets, majority of layers, so compute power, are responsible not to do the final classification, so to assign a picture to one of predefined classes, let's say, but to detect useful feature, visual feature in this case, starting with simple one like lines to more complex, like, I don't know, eyes or whatever else. So you can get a model that was trained already on thousands of those images, how to detect those features, and transfer the knowledge. I mean, just use pre-trained parameters to adjust the deep neural net to your own needs, just by training the very last part of this net, the part responsible for classification. To achieve this, and we are doing this for years, so it's nothing new, of course. To achieve this, we are going to freeze during the training. We are going to freeze all those hidden layers and retrain the model based on our own examples, labeled data, if you remember, to detect, to assign, and now I'm talking about classification, but as you will see, there are different kinds of tasks, to assign a picture to one of predefined classes. And as you will see, this transfer learning is quite powerful. I'm going to adapt models trained on regular pictures, like those ones, to X-ray or microscopic images. At the first, they are completely, you can think about this as completely different things, but still, it's efficient, which is great. That means that some of those challenges can be, well, you can get rid of the need for huge amount of data and compute power by using transfer learning, a first part of the solution. Still, which base model should I use for my model? How to set those hyperparameters, parameters that will guide the training procedure and my final model architecture. A lot of very important choices to make. And it's actually impossible to say in advance that this or that based model will be the best in my case. I have to try. Multiple tries. And for that, AutoML is great. So AutoML can be, and right now almost, I think every machine learning library is enhanced with AutoML capabilities. So you can do this in scikit-learn, for example. Basically, it means that that's the hyperparameter search space, like the set of algorithms, data preparation techniques, and hyperparameters. And I have to find the best combination of all. So I'm going to search in this hyperparameter search space, in which an algorithm itself is also one more hyperparameter. So it's a hierarchical conditional search space. Probably the first attempt will be not the best, but I'm going to iterate among, well, a set of combinations, candidate models, as we are going to say, and finally, hopefully, we'll find the best combination of those hyperparameters. And with this, we are ready to deploy and start using our models. Okay, nothing new, you would say, but, and this is a huge but, right now, we can use AutoML for computer vision in Azure Machine Learning Service. This feature is still in preview, so you have to use Python SDK. The graphical tools are still not available, but it's probably not a huge issue for all those of you who are Python programmers. Even if it is, hopefully soon, the support for no-code environments will be there as well. But we have to start with data. So the first task is to classify images. And I'm going to use 3 different data sets, publicly available data sets. And let me switch to this. So that's the Azure Machine Learning Studio. Hopefully you can see, I can zoom in a bit. If it's better, let me know. And here, what I did, I already registered a set of data sets. That's the first one we are going to use. X-ray training and validation data sets. That's the source, by the way. And what I did, I just selected a small subset of this huge data set, just 150 images, X-ray images labeled as COVID, normal, or pneumonia. So that's the structure of this data set is actually needed. It must be like that. You have to register the data as a tabular data set in which each row will contain a path to an image like that and a label. So it's not typical data set for computer for image classification, I know, but well, you can automate the process of and you can automatically convert classical data sets. Basically, it looks like this, yeah. So you have a folder with subfolders per class, all COVID images, pneumonia images, and normal images stored in subfolders. And with this, we can programmatically create a JSON file and then use this JSON file to register a required tabular data set. So what I'm doing, I'm showing you one of those images at random. Yeah, I just told you about those images. And here I'm saying that 10%, so 5 images per class will be removed from training data and put into validation data set. It's almost nothing, 50 images per class. So I did it. And then I uploaded the original JPEGs to Datastore. It's basically a storage account associated with this Azure Machine Learning workspace. Again, feel free to ask questions. And based on this, okay, I created a JSON file and use this JSON file to register, I will show you it, to register a dataset. As I told you, a path and a label. That's it. The hard part, so the data is there. Now the fun part, modeling part. Okay. As you can see, I was using this version 1.38 of Azure ML SDK. And yeah, I'm connecting to this workspace. And then I'm using a cluster, which is actually great. That means, and the cluster is here. I'm going to show you all those stuff, at least during the first experiment. So there are my compute cluster based on NC6 virtual machine. So it's GPU powered virtual machine. In NC6 contains 1/2 of the Tesla K80 GPU accelerator. Basically, it means 12 gigs of GPU RAM. The whole K80 card is available in this cluster. It will be needed later. So I'm using this compute power. And then I'm going to define the experiment, and the experiment name is important. So let me copy paste this name to a clipboard. That's my training data, the validation data set. Good, it looks like this. You know this already. And this is the very simple example how you can use AutoML for image classification. So you have to define AutoML image config object. That's the task, image classification. The experiment will be launched against this compute target. The training data is here, the validation data is here. And now I'm not doing AutoML a lot. I'm just choosing a base model, ResNet in this case, a single model with default hyperparameters. So the number of iterations or candidate models is set to 1. With this, I can send or submit this experiment for execution, and it will take a few minutes, okay, and I got a model. But, and this is an important but, let's move to the second step and try different hyperparameters. So for that, I'm going to define this hyperparameter search space. Let's say that I'm going to define a learning rate as a numerical hyperparameter. The mean value is 0.01, the max is 0.01, and it's a uniform distributed variable. Then there is a categorical hyperparameter, the optimizer. I will check the vanilla stochastic gradient descent and the ADEM. The training batch size was set to 16 to avoid out-of-memory errors. And now I can provide a set of base models. So that's the ResNet architecture. If you have no idea what a ResNet is, all links are, as you will see shortly, are in my on my slides, and those slides will be shared with you. So feel free to learn more. Probably you have no time to discuss all those architecture, but maybe you will ask. With a different, variants of ResNet and completely new architecture, not based on CNN, convolutional neural nets, but on attention. So the concept, which is quite popular on NLP, natural language processing. The basic idea is to find a good representation, but not for words or phrases, but for those graphical features. So here, in both those models, a small part of an image, 16 pixels, are treated as a phrase, let's say, and then we are trying to find a good, meaningful representations for those small areas. And now I'm going to check 10 candidate models, 2 in parallel, by selecting randomly from this huge hierarchical namespace. And in addition, I'm going to use a bandit policy to stop some runs earlier. I will explain this. Okay, and then with this, I'm ready to execute my task. Probably, let me sync with the slides, and then we are going to talk about the output of this experiment. So that's the dataset, a tabular dataset registered in Azure Machine Learning Workspace, containing a path to uploaded images and labels. Then I define the image classification as a task. Some data augmentation techniques will be applied for me automatically. which means that actually I'm going to, those candidate models will be trained on more than 45 examples. If you remember, 10%, so 5 pictures were removed from training dataset and will be used for validation. So the horizontal flip, color jitter, normalization, random resize, and cropping will be applied for me automatically, increasing the number of training data, training images. Right now, we have no control over this data augmentation techniques. So there is no experiment option exposed, but it probably will be. Now, model algorithms. Here are those links I mentioned. And actually, if you are new to computer vision, I strongly recommend to read those research papers in this order. Start with ResNet, and then have a look at those, well, variation of those ResNet architecture. MobileNet is a simplification of ResNet. So you should know how ResNet works before you will move to this one. And finally, have a look at this. Attention is all you need. Then I was able to define the hyperparameter search space. There's more hyperparameters that can be set, of course. The sampling methods I used is random sampling. Right now, it's the only one supported for conditional hyperparameters. Why conditional? Because for some models, a different set of hyperparameters can be set. I mean, base models. And please use those early termination policies. I use a bandit policy, which means that the some runs, the training of some candidate models will be stopped earlier if those models are not good enough at this specific stage of training. And you will see this in action. So with early termination policies, you can save a lot of time, which means a lot of money. And with this, we are going to have a look at the experiment. This one. Good. Okay. So that's the master run. Train accuracy and accuracy. It's completely up to you what kind of metrics you would like to have a look at this master or parent run. So it's configurable. You can even share those charts with your colleagues. And the last run is this one. Okay. It took me 25 minutes. Well, what does it mean? Let's have a look at child runs. That's the coordinator. Hyperdrive run. And here you can see all those child runs. And interestingly enough, some child runs terminated earlier thanks to this early termination policy. They were not good enough at this stage, so probably they will never reach this quality, even if we let them finish. I mean, the training will. So it's better to terminate them earlier. Bandit policy. And here you can have a look at this hyperparameter search space. So different learning rates, chosen randomly, different optimizers, training batch size was 16 all the place, different candidate models. As you can see, the accuracy, so the primary metric for image classification tasks is not distributed randomly over the search space. Some combination of hyperparameters tends to yield better models than others, which is interesting by itself. Based on this experience, you can adjust the search space and train even better model. So that's the model I got. And this is the best one, looks like. So let's have a look at this one. And here, all metrics are accumulated for me. Looks like a perfect model, isn't it? So accuracy, validation, confusion matrix, good. Let's have a look at confusion matrix as a chart. We should be able to see it. Oh, there you are. Three cases, three classes, and that's true labels and the predictions. And yeah, my model was able to correctly classify all 15 validation images to the right class. So that means that we are ready to deploy the model. The important part is that for image classification, the accuracy is primary metric, and you have to use it, at least now, to compare all those candidate models. Accuracy is relatively simple. Yeah? It's the percentage of right predictions versus all predictions made by the model. But you can also change the task from image classification to image classification multi-label. And you will do this if on the same picture you will have, more than one objects, like a cat and a dog, or whatever else. And if that's the case, you would like to classify this image as cat/dog. Multi-label classification. Yes, you can do this. I'm not going to show you this because it's pretty similar. It's still image classification to the previous task. But keep in mind that the primary metric will be different. It will be intersection over union. So you have to think about those bounding boxes, the smallest rectangular areas containing the whole objects. That's the ground truth. And that's the predicted ground bounding box for this cat or dog. Yeah? So per object visible on an image. They may not be ideal. Yeah? So they may be like this. So the common part is the overlap. And the union, well, it's a union. You can divide this one by this one, and you will get intersection over union. Beta. The higher, the beta model. Okay, so I did this for my model, the best model. So I registered this model, not that hard, and then I deploy it. So that's the run from which I'm getting the best child, the best candidate model. And to deploy a model, you have to actually deploy a pipeline, which means it will be a Python code. And to successfully execute a Python code, you have to have a virtual environment. That's the scoring script generated for me automatically, and this is the environment. Also generated or defined for me automatically. So I'm just showing you all those libraries needed to use the model. So the deployment by itself is not that hard. Don't forget that computer vision model tends to be huge. So you have to have enough memory. Maybe you spot it. I'm not using a GPU-based compute here. It will be a CPU. Yeah, enough for prediction if we are not trying to get the lowest latency possible. Okay, the operation succeeded. So with this, I can use a test data, one of those JPEG files, and I'm going to send the data to the endpoint for predictions, and I will get the result also in JSON form like this. So with a small Python code, I can convert those predictions to something like that, an image with the class and the probability score. That's it. With 15 images, 25 minutes of training, I train my perfect model, looks like, by adapting one of the candidate, the base models. Maybe you spot which one was actually the best base model. To my task, I deploy this model, I can start using it. I think it's great. And with this, I would like to change the gear and show you additional tasks. The second task for computer vision is object detection. This is a slightly different task, more complex. Object detection means that there may be multiple objects visible on a single image, and the goal of the model is to localize all those objects and assign those objects to the correct classes. So this looks like a regression problem because you have to find those bounding box coordinates. And this looks like a classification problem. In addition, you have to do this, you have to perform both tasks, not once per image, but once per candidate area. Okay, more complex. But again, probably you guess that the experiment will look very, very similar. That's the dataset registered already. Again, an image URL and labels and bounding box coordinates. All this is needed. And I'm using just 300 of images. Again, a very small subset based on publicly available data containing red blood cells, white blood cells, and plateaus. And the dataset is, by the way, highly imbalanced, as maybe you spot on this image. So, when I have my data there, the next step is to define an experiment, so to do the modeling. Data augmentation techniques are slightly different. For example, and this is important, and the random crop around bounding boxes to help those models focus on what's important on an image, not on the noise. The algorithms or base models are, of course, completely different. You can choose between you only look once models, the 5th version of this model described here, or a faster RCNN, ResNet. You know already what a ResNet is, but here there are two tasks. First, all those candidate areas will be detected, so region proposal task. And then we are going to do this regression and classification tasks per proposed regions. So two you only look once, it's different architecture. And finally, there is a RetinaNet, ResNet. So both those tasks were combined again into a single task, but the architecture is different from YOLO. All were described in those research papers. So, your goal is to set some hyperparameters to define the hyperparameter search space. You know that for sampling methods, only a random sampling is supported. And again, don't forget to set or to define early termination policies. The most important part of this experiment from your perspective is that you will get a set of candidate models, and one of them will be the best one. Here, to compare all those candidate models for object detection task, mean average precision is used as a primary metric. Okay, and so if you don't know what a mean average precision is, feel free to read through the definition or search through over the internet, because otherwise you will get lost. Why this model was better? The intuition, it's not the average of precision. If you think about the precision as precision calculate based on confusion matrix, no. It's based on actually those these are intersection over union metric. So first you have to get familiar with intersection over union, and then if you think about this, those predicted boxes, there will be a lot of them, and majority of them will be removed because the score will be too low. This threshold will be too low. So if you change a threshold, you will get more, or by changing a threshold, you will get more or less predicted boxes for the same image. Which means that for some of them, this intersection over union will be lower. For some of them, it will be higher based on this threshold. So if you change a threshold, you will get a different score for your model. And you have to have a single metric, otherwise it will be almost impossible to work with. That's why all those average precisions will be combined, I mean for all object predicted boxes. Again, the higher value, the better model. And yes, I did this here. So let me switch to a different experiment. Now we are talking about blood cell object detection. Good. And the experiment, well, it's the same cluster was used. That's good. And this is the name of the experiment. You would like to have a look at the experiment as well. Now we have to convert the original data, so XML files, into those JSON files or with very specific format. So I did this, and based on this, I was able to upload the data and register my data set for object detection task. Good. So it looks like this. A path, those details are not that important. Label, there will be multiple labels, and bounding box coordinates. Modeling part. Just define AutoML image config and set the image task to image object detection. Now it's a single base model, so it's like a starting point. The default parameters for YOLO v5 base model. I did this, and yeah, it succeeded, but then I start doing this hyperdrive search. So again, a learning rate, training batch size were defined on the experiment level, and then there are model specific parameters for YOLO. I choose between small and medium, and the image size. The original images were larger. I have to resize them, otherwise, out of memory exception. And for faster RCNN, you can set a specific number of parameters, like, I don't know, box detection per image. Again, the max size. Now I decided to check 20 candidate models, the same bandit policy. So I'm sampling those hyperparameter search space randomly. And then bandit policy was used to stop the training of all those models that after 6 epochs were worse were in the 20% of the worst performing at this stage models. Okay, so that's it. Now it's time to launch the experiment and then download the scoring file and the virtual environment definition. With this, I was able to deploy my model one more time and use it. So that's my test image. I send this test image for prediction, and the result looks like this. Probably it will be slightly better to show you this like that. Not bad. Red blood cells and white blood cells, all, but that was the second experiment and the second type of task. And it took about an hour. Okay, maybe there were multiple runs. So let's have a look at children. 1 hour to check those. Okay. And I was playing with different hyperparameters. Not all of them are already functional, as you can see. So the parameter search space actually used was like that. But basically that's good, because it means that even if some child runs will not be executed, they failed, other will finish, and some will be cancelled based on score, the current score. And this is this hyperparameter. You can switch from parallel coordinates charts to different charts. Still, you have to find the one that that works for you the best. Looks like this model was pretty good. Precision 1, recall. So in 1 hour, based on 300 images, I was able to train a ready to be deployed model. Nice. And the very last task, 5 minutes, I know, is instance segmentation, the most complex computer vision task that you can automate right now using Azure Machine Learning Service. Have a look and compare the original images and the enhanced images with segmentation. Which ones are easier to analyze? Obviously the right ones, because all objects were detected, and if objects belongs to the same, all objects that belong to the same class were combined. So the instance segmentation is commonly used to improve the readiness of those images. And now I'm using different kind of cells, including breast cancer cells, to spot them easily on images. Okay. Right now, only one base model is available for this, mask RCNN ResNet, described here. Data augmentation, more or less the same as for object detection. And nothing new, exactly the same sampling methods, early termination policies, and hyperparameters exposed. Even the same primary metric, I mean mean average precision. So with this, probably we are going to have a look at the very last experiment, which was slightly more expensive, not data sets by experiments, sorry for that. Or maybe we should even start with notebooks. Probably you are interested in code as well. So cell segmentation, and let's move to the segmentation. So let's skip the data preparation part. As always, I have to connect to my workspace and upload data to a data store or download the dataset from the data store. In this case, I'm registering a dataset, looks like this. Good, then I'm selecting a subset of those cells. And it looks like this for those subsets or those selected cells. Nice. This is my experiment. So I'm defining the experiment. And I will start with, baseline. So the only available base model and one iteration. Small number of, I had to change some hyperparameters, otherwise I will get out of memory exception, even if I'm using the NC12 cluster, so 24 gigs of GPU RAM. It's still not enough for this kind of tasks. Keep those challenges that we started with in mind. Okay, so I launched this experiment, it succeeded, which was great. And then I start playing with the different model version, sizes, and set of hyperparameters, so a lot of learning rates to choose from. The box detection per image, by default, it's 100, as I read in documentation, but here, it's a huge number of those cells visible per image, so I increase this number. I run this for 8 iterations, okay? And then I deploy the model, the best one, and use it. So now I can compare the original image, the ground truth segments, and predicted segmentations. If it's large enough, you probably will spot that this is not that bad, not that far from ground truth, but still it's not ideal. Okay. So I was able to do this. And if you have a look at the experiment, live self-image segmentation, it took a bit longer, 31 hours. All those failures that maybe you spot them were due to out of memory exceptions. Okay, child run, that's the hyperdrive run on the NC12 cluster. And here, child runs, looks good. Those two were terminated earlier. Good. This is the best one in my case. Maybe 8 candidate models was not enough. It's a relatively small sample. Probably I will get better models just by checking more combinations of those hyperparameters, as you can see right here. So this is my best model, the one that I showed you, the predictions returned by this model. 5 hours to almost 6 hours to train this model. That's my model. Okay. And by the way, you can download this model. You can deploy it like this. So zero code deployment. You can use it locally. You don't have to use Azure Machine Learning service or workspace for predictions. And well, just 4 metrics are logged automatically for this kind of tasks, image segmentation tasks. But I was happy enough with my models. I deploy it and I use it. And with this, let me wrap up this session. The last chance to ask a question, by the way. Hopefully, I showed you and convinced you that all those challenges, you can deal with them if you have the right tools, the right environment. And AutoML can be applied to computer vision with addition to transfer learning. So it's slightly different thing. We are not training those models from scratch. If we try to do so, instead of 31 hours for the last task, I will spend months actually to get similar results. And still, the performance of those models trained from scratch will be way, way worse. It's a common knowledge, yeah, that transfer learning is used not only to shorten the training, but also to improve the model quality, performance. It's almost impossible to get the same result as those huge AI-oriented companies that build those and published and made those base models for us available. So my point is, computer vision can be automated. And by doing this, you can significantly reduce the time and cost and increase your chances of success. Behind the scene, the combination of transfer learning and AutoML are used. This is a new feature, a new area. A lot of work is, well, in progress. So you can expect even more advanced or more useful features being added, not only to Azure Machine Learning Service, but to other environments, other frameworks as well. Okay, no questions. Maybe you can find me later as well. Find me on LinkedIn, for example. Why not? The time is almost up. So again, I would like to say thank you for having me remotely. Trust me, I would love to be with you in Sofia right now and deliver this session in person, but still I'm grateful for invitation. Hopefully, you found this session interesting and useful. And thank you very much. And see you soon.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Our customers have been trusting us for over 150 years now. Our apps rank amongst the best banking apps, and more than 1.9 million customers are already using our apps on a daily basis. We have big plans and want to extend our feature stack. What can you expect if you join our digital banking solutions team? A highly motivated agile team setup, a balanced mixture of talents and professionals, a collaborative environment with colleagues of 40 different nationalities in 4 locations, a scalable and modern technology stack with Microsoft Azure and Google Cloud Services, a flexible API-based ecosystem, CI/CD with up to 30 releases per year. We want to grow together with you. Check out our latest job postings.
Stripe Bulgaria was founded in 2000.